So I welcome again for the fourth session, second week, everyone, both from India and USA. Very good morning and good evening. Today's agenda is again Langgraph, agentic framework with theoretical and one project end-to-end explanation with code execution and all. So before we moving to the main demo execution, so I would like to give a couple of points to for the new joiners, right? So this is like a 20-hour agents and agentic framework demo programs. So we thought of giving a free demos to everyone in the October month. So there are like different concepts. So there are multiple frameworks. So we start with LangChain in the week one, and two projects we explain on LangChain with theoretical AI agents. So the recorded will be shared to many people. And this week, yesterday and today, we again giving demo on 4 hours. Yesterday we done with 2.5 hour session, and today we are going to discuss about 2 more hours on Langgraph. And the next week we discuss about few more framework like Crew AI and no code tools as well. That as per the agenda and as per the plan. So I request everyone to utilize this program and make sure you all enroll and join with us. So we teach 100 plus hours, close to 90 to 120, 90 to 110 days. It all depends on how much time we spend on in a week, right? So we execute like 100 plus hours across course agenda. We'll be sending the course plans to everyone in this group. For coders, we teach AI for coders, AI for cloud platforms, which includes three areas: AI, Azure OpenAI, Amazon Bedrock, Google Vertex AI, and along with cloud platforms, there is a separate AI for coders course plan. Each and everything will be there, and prompt engineering. So these three packages come under AI for coders. For AI for non-coders, there is a separate course plan for AI for non-coders. Non-coders course plan plus prompt engineering plus we teach AI tools as well. So along with that, there are certain 20 hours of project plan, like AI tools where these AI non-coders, there are like Scrum Masters, testers, BA, data analysis, data analytical people. There are 10 plus tools we teach from non-code side as well. So that is the in detail course plan we'll be sending and we'll share here in this group. And coming to our execution for this 20 hours boot camp, so totally we planned for 10 sessions and 20 lab hours. So last three sessions we almost gave like 1 hour theory and 2 hours practical. We also spent half an hour for Q&A also. So totally we spent three plus 2.5, almost 8.5 hours we spent till yesterday. So the recordings, if someone wants, please ping us, or you can subscribe to our YouTube. So the demos will be uploaded there. And today we discuss about one more project on Langgraph. And next week we go with as per the plan, no code tools. And next week, we teach two projects, two use cases on MCP. MCP project one with end-to-end theoretical and code execution. And Sunday on the same week, MCP project two use case, we teach theoretical and one use case completely end-to-end code execution. And the last week, we also teach RAG applications and no-code tools. So this is how the free program we are trying to execute in this month for 20 hours. Um, so session one is completed. Session two, LangChain is completed. Session three, yesterday we completed with Langgraph. Session four, we are going to work on Langgraph project two today. Session 5 next week we are going to deal with Crew AI and multi-agent system with theoretical and without theoretical with code also. And then the fourth week like I talk project one on MCP with the theoretical and code implementation, one project. and another project with theoretical on the same MCP project. So every framework, every important trending concept, we are trying to explain 5 hours of awareness session to make everybody comfortable to take our enrollment. Okay. And similarly, we also teach a lot of AI tools where you can leverage into your business in your real-time work as well. So as per and the cloud platforms also, we using Google Vertex AI, we try to demo end-to-end chatbot building and coding as well, with code and without code. So this is a summary of 20 hours program we are going to execute till entire October month. Um, the course plans and other details will share uh, offline. Please feel free to ping us and follow our chat group here, webinar chat group. And we controlled everyone not to unmute or not to talk because it should not during the class. We don't want to disturb class. So for Q&A, questions and answers session, you can raise your hand. You can chat in the chat bot. You can use Q&A feature within the webinar, and we will try to spend 30 to 40 minutes in the last. So park your queries in the chat group, and definitely we'll help everyone, and we'll try to resolve everybody's queries. So with that, I'm handovering to my mentor Ganesh Atmakori, who is an agentic engineer, who is going to present today on Langgraph. Ganesh, please proceed.
Thank you. Thank you so much, sir. So, good morning, everyone, to the people in USA, and good evening to the people in India. So, welcome to today's session on Langgraph. I'm really excited to be here with you all today. So, before starting, let me quickly introduce about myself. So, my name is like Ganesh Atmakuri. So, I'm a data scientist, agentic AI developer, currently working at AT&T. So I have about 3.5 to 4 years of experience working with various AI technologies, currently in the areas of generative AI, natural language processing, deep learning, machine learning. So I worked extensively with LangChain, Langgraph, and built some production-ready AI applications. So I'm very passionate about this, making AI concepts accessible and very practical for everyone. So apart from my corporate work, I also teach machine learning, deep learning, Gen AI, agentic AI. So currently I mentored over 200 plus students and also handled open source project as part of KKR Gen AI. So that's a quick introduction about myself. So now, yesterday you had your first session on Langgraph. So where you learned what Langgraph is, and you saw some basic components like nodes, edges, state, and explored some examples or some practical examples of how Langgraph works, right? So I think you got a solid foundation on the basic concepts. So today we are going to build on everything what you learned yesterday. So and we'll take it to the next level today. So we'll explore some advanced patterns and we'll deep dive into some different workflow strategies and understand how to integrate human oversight and see how Langgraph so it fits with the rack systems and all. So we have about let's say like 1.5 hour to 2 hours today, maybe. So let's make the most of it and see this advanced concept in detail. So let's get started. I'll quickly share my screen. I hope everybody can see my screen. Can I see some chat messages? Can I see some confirmation messages?
Yeah, we can share. Yeah, thank you.
Thanks, thank you. So, all right, let's quickly refresh what LangGraph is before we deep dive into some advanced topics. So first, what is Langgraph? So you already saw yesterday, but just I would want to make a quick refresh. So this Langgraph is some orchestration framework built on top of LangChain. So while LangChain give you some chains, some linear sequences of operations to build your RAG applications, here LangGraph gives you graph, which are more powerful and very flexible to build your AI agentic applications, right? So going to some core components. So in LangGraph, you have something called as nodes, edges, state, graph, everything, right? So nodes is basically individual processing unit. So each node does one specific job. It would be like calling an LLM, fetching data from a database, or processing some information, or making some decision, right? For example, let's say you have a node that takes a user query and reformulates it, and there is another one more node that searches a vector database, and there is another one more node that generates the final response. So each node is performing each unique task, or else each node is performing some specific task, and output of one node, it depends on output of the other node. Okay, so that's how what the node is meant by. So it's an individual processing unit. Okay, in short, node is a function which does some action. Okay, so next we have edges. So edges are nothing but these are the connection between nodes. Okay, they define how information flows through your entire line graph. Okay, for example, imagine there is a road. Okay, there is two different cities and there is a road in between them. So road is connecting two different cities, right? That's how edges connect two different nodes. So edges tell the system, after you complete this task, go here next. Okay, that's what the edges is meant by. So and next we have something called as state. So state is a shared memory of your entire workflow, of your entire Langgraph workflow. So this state carries some information as it flows through this graph from one stage to another stage. As it is flowing, the state carries some information with it. Okay, like for instance, let's say it might contain the user's question at first. Okay, and the document retrieved information at next, and next step, the final answer at the next step. All will be combined in the state. Okay. First, user is sending the question that will be saved in a state, and some documents or some results are retrieved from vector database that is again stored in the state. That means it's appended in the state. Okay. And at the final step, the final answer is generated, and again it is stored in the state. Okay. And finally, we are getting the output from the state. Okay. So, at a short, state is like a shared memory. Okay, it contains the data of your entire workflow. Right. Next, we have graph. So, graph. This is the complete picture now. Okay, all your nodes, edges together, they'll form the entire workflow. Okay, it's like big picture. Like if you see this graph, look at this diagram at the right side. So there is a start node. Okay, there's a start node first, and then this is the typical rack system, typical Langgraph system, which is based upon the graph. First, it starts and then it retrieves information. There is a retrieval node. So this retrieve, it is a node. Okay. So this retrieval node, it retrieves some document or some information. And now next, you have the another node, grade documents. Okay. So it will create those documents. Okay. And based upon the quality, so let's say there is some information retrieved and it is this grade documents node, this function graded those documents, and based upon the quality of the documents, so what it will do, so based upon the quality, either it can generate the answer. If you see these dotted lines here, generate answer. So if the documents grade is good enough, it will generate the answer directly. Or if it is not good enough, it will go to this node, rewrite query. Okay, and it will rewrite the query and it will do some web search for additional information, and both again combine and generate the answer. Okay, here grade documents, it is a one more specific node. Okay, it is like some conditional node. Okay, so based upon the quality of the retrieved documents. It will generate an answer, or it will go to rewrite query and do some web search, add some additional information, and finally generate the answer. Okay. So this is the complete visual representation of how typical Langgraph workflow looks like from start to end. This is a complete workflow from start to end. In between this, retrieve, create documents, rewrite queries. So these are some nodes. Let's say this web search is a tool node. Okay. So on generate answer, this is one more node. And if you see these arrow marks from retrieve to create documents, from create documents to rewrite query. So these are edges. Okay. From retrieve, after retrieve, it should go to create documents. How it is connected? By this edge, by this arrow mark, by this edge, and how the information is flowed from retrieve to create documents, and how the create documents is getting the input through the state variable. Okay, so this is the complete picture: nodes, edges, state, and graph. So this is your entire graph. These are your edges from retrieve to create document. This arrow marks these are edges, and this retrieve create documents. These are your nodes. Okay, and state is shared object. Okay, so at first user question that will be stored in a state. First it will be at the retrieval level, and next the state goes to the grade documents. Okay, and it will create the output. The output of this grade documents will be again stored in the state. Okay, and finally, let's say if it goes to generate answer, the answer will be generated in the state once again, and the final LLM response will be generated based upon the state. Okay, this is what the Langgraph is. So this is the key components in your Langgraph. Okay, so next. So now you might be thinking, we already have lang chains, then why do we need lang graph? Okay, so if you look at this diagram on this left side, chain one, chain two, and all, so these are some traditional chains. Okay, I guess you are familiar with the basic rack structure. Okay, first, if you see this, if you see this chain, okay, you grow from let's here there is an input. Okay, you go from input through chain one, and output of chain one becomes the input to chain two. Okay, and finally to the output. Okay, so here this is some sequential process. First there is information, and next that information, this input will be passed through chain to the chain 2. Okay, output of this chain 1. So let's say in this chain there are some processing. Let's say there is some prompt, there is some LLM, there is some function, some processing is happening in chain 1, and output of the chain 1 becomes input to chain 2, and again in chain 2 there will be some processing happens, and finally you will get some output. Okay, this is like just traditional rack structure. Okay, so in this case, in this chain, what if you need to go back and retrieve something? Let's say in your chain two, so there are some parameters missing. Those parameters need to be generated from chain one, but there are no parameters from chain one. So what if you need to go back and retrieve something? Okay, so that is one question here. Okay, so here the chain is connected sequentially one after the other. Here in this chain, you can't go back directly. Okay, as it is connected sequentially. No, so also, you want to take sometimes you want to take some different paths based upon the quality of results. Okay, let's say here output of chain one. So here some output is generated from chain one. Okay, and based upon that output, you need to take some different routes for processing. Okay, so how would you do that in the lang chain? Okay, and also sometimes you need to run some multiple operations simultaneously. What if you need to do that one? Okay, and what also if you want, so some processing is happened, some output is generated, so finally this is a AI generated output, right? So it might be right or it might be wrong. Sometimes you want a human to review it and approve before processing. Okay, so if you're, let's say if you're building simple rack, that simple POC for your personal use case, that's okay. If the output is wrong, then you might adjust it once again, and you will regenerate the output once again. But what if it is a production applications? So without testing, how would you deploy it? So what if the AI generated response is incorrect? So you need a human to review and approve right before proceeding. So these simple traditional chains, these can't handle all of these scenarios. So that's why we have Langgraph solutions. Okay. So the first advantages of using Langgraph is it gives us cyclic graphs. Okay, this is very huge topic, cyclic graphs. So you can create loops over here. So let's say um, you are building some content generator application. Okay, content generator application. Okay, so let's say you built with cyclic graphs. Okay, cyclic graphs in the sense, so one node is connected to another node, and again that node is connected to another node, and the last node is again connected to the first node. So you know the circle, right? Each other is connected. Okay, so let's say you are building a content generator, and you have cyclic graphs, you implemented cyclic graphs. So now your workflow, it can generate some content. Okay, let's say first node, it can able to generate some content, and second node, it check the quality of the generated content. Okay, and if it is not good enough, it again loops back to regenerate. Okay, let's say there are three different nodes. First node is generate content, second node is checks its quality. Okay, and based upon that quality, if it is not good enough, again it loop backs to the first node. What is the first node? Your generated content node. Okay, it will again go to that first node and regenerate it once again. So that is what a cyclic graphs, each other is connected, right? So if it is not good enough, again it will go to the first node and it will regenerate once again, and it checks the quality once again. Okay, and if this time if the quality it meets, then it will gives us the response. If not, again goes to the first node, right? So it keeps improving until it meets our standards, right? So this process, you can't easily do this process with simple chains. So this is a simple chain. This is simple lang chain. Okay, you can't do this with a simple chain. You need some cyclic graphs. So that's what lang graph gives you. Okay, and also the second advantage is conditional routing. Okay, so sometimes your workflow need to take some intelligent decisions. Let's say you are building some customer support chatbot. Okay, based upon the customer query, your graph need to route to different parts. Okay, let's say you have three different nodes: simple FAQ node, okay, and some technical issue node, and some complaint node. Okay, you have three different nodes in your line graph. Okay, so now the graph decides dynamically. So which part to take based upon the user question, based upon the user query. If that is a simple FAQ, then it will route it to the simple FAQ node. Okay. If it's related to some technical issue, then it will route it to the technical issue node. Okay. And if it is some complaint based upon the query, some like user is complaining, so it will go to node 3. Okay, like it's an escalation workflow, let's say. Okay, so the graph deciding here dynamically which path to take. Okay, one node is deciding where I need to route it to, either to node 1, node 2, or node 3. So that is the conditional routing. So dynamically selecting which route it needs to take. Okay, next, another one more advantage is human in the loop. Okay, this is very critical for production systems. Okay, let's say um, there is an AI system that is generating some social media post for some brand XYZ. Okay, so before posting, um, you want your marketing manager to review and approve. Okay, so social media posts, so the AI is generating that, and there is marketing manager who needs to review and approve. Okay, so now what Langgraph will do here is, after creating a social media post and all, Langgraph, it will pause the workflow, wait for human approval, and then it will continue. Okay, so see here what is happening. After generating the post, your workflow stop execution, and it wait for some human input, some human approval, and then only it will continue. So let's say if the manager makes some edits, and mm, the manager, or if a marketing manager making some edits and changing some post, and again he's giving some additional instructions, then what your LangGraph does is, it will again goes to the first node, it will regenerate once again, and again comes to the human approval stage. Okay, so it is learning. Okay, it is learning from the human. So you here, the entire workflow is again changing based upon the human query. So before approval, human is giving some input or some additional changes or some modifications or suggestion, whatever. Okay, based upon the suggestions, your land graph, it will again go to the first stage and it will again generate the social media post and it will again come down for the human approval. This time, if the human is approving, then it will go and post it in some LinkedIn or some social media. Okay, whatever. So these capability, this human in the capability, human in the loop, this capability, it is making LangGraph production ready and enterprise grade application. Okay. So nowadays, many of the organizations are using this framework LangGraph because of these reasons: cyclic graphs, conditional routing, human in the loop. Okay. So this human in the loop is very critical. Okay. When you want some production systems to be built. Right. Next. Now, now let's talk about some fundamental and advanced workflow patterns in your LangGraph. Okay, so these patterns we are regularly using it in the LangGraph. Okay, now I'm going to explain each pattern conceptually first. Okay, then show you I mean some architecture diagram how it looks like sort of. Okay, first let's go with prompt chaining. So see this diagram here, prompt chaining. So this prompt chaining, this is the one of the let's say it's a first workflow in your LangGraph. It's a basic workflow in your LangGraph. Workflow in the sense there is a start node and there is an end node. In between there are different nodes and each node is connected with an edge and there will be some conditional routers. There will be some tool calls and everything. So this entire setup is called a workflow, right? So now let's say the first workflow we are going to discuss now is prompt chaining. Okay, let's start with this. So this is the most straightforward pattern. Okay, so your prompt chaining. So this is a sequential execution. Now here output of one prompt becomes input for the next. So there will be LLM call. So obviously agentic AI applications means there will be a LLM. There will be LLM call. You will give some prompt. Based upon the prompt, your response is generated either directly from this LLM brain, or from some retrieved documents, whatever it is. So we need some LLM call over here, right? So this prompt chaining is a sequential execution. Here, output of one prompt becomes input for the next. Let's say, um, let's say you are writing a research paper, okay? So let's say this workflow is about writing a research paper. Now, there will be some particular steps in your workflow. Let's say step one will be analyzing the research topic and generates an outline. Okay, this will be step one. Let's say this step one execution is done by node one. Let's say there is an analysis node. It will based upon the user query. It will analyze the research topic and generate some content. Okay, and now there is another one more node. Okay, at step two. Now, now for each section in the outline, so it will write some detailed context. Okay, at first stage, it will do some research and it will give some sections. Okay, these sections need to be researched more for final analysis or not. At step two, at node two, it will write content for each and every section. Okay, which it is detailed in the step one. Okay, let's say at step one, it is generated, we may require these sections like introduction, literature review, and some previous experiments. Okay, and some abstract, these sections. Okay, first step it generated these sections. At step two, entire content is generated for each of the section. Okay, and now at node 3, step 3, there is one more node. What it will do is it will review and refine the language if there are some grammatical mistakes and all. Okay, and there is one more node at stage 4. Let's say that node, it adds citations and references, everything. Okay, and at step 5, the final node, it will create some execution summary. Okay, here if you see this, so this is some sequential pattern. Here each step uses the output from the previous step. Okay, step 2 uses the output of step 1. Step 3 is using the output of step 2, which is the combined output of step 1 and step 2. And again step 4, that is node 4, it is using the output of your first three nodes. Okay, and the fifth node, which is creating an execution summary. Okay, how it is generating summary based upon the output of node 1 to node 4, right? So here each step it uses the output from the previous steps. So this is how a sequential execution looks like, your prompt chaining looks like. Okay, and also if you look at this chain, so here first input is flowing in and it comes through an LLM call. And also, at some points in your prompt chaining, at some points there will be some gate. Okay, gate means some decision point. Okay, so based upon the decision, this flow either fails or goes to fails if something wrong, or it can continue generating some more processing nodes for final output. See this, there is an LLM call and some conditional, some decision point. Based upon decision point, it may fail or it may generate further nodes. It will process further nodes. Okay, but eventually it is output of each step is depending upon, I mean, input of each step is depending upon output from the previous step. Okay. So this LLM call, it will generate some response. Okay. It goes to the decision point. And if it is yes, it goes to this processing node. Here, these nodes get the information, gets the input from this node, previous node. Okay. And again, processing. Okay. This one, final node. Okay. This will get the input from the previous nodes. Okay. Each node is depending upon the previous nodes. So this is your typical prompt chaining looks like. It's a sequential, it's a sequential process. Okay. So it's like mostly linear, but sometimes it may have some conditional branches like this. This is a gate. Gate is nothing but some conditional branch. Okay. Some it may be linear or maybe having some conditional branches. But the key characteristic here is as this move forwarding, so it's completely like moving forward only. So output of one step is depending upon the previous step. Okay. It's like a pipeline. Okay, where each stage adding value to the output from the previous stage. Okay, so that is what the prompt chaining means. Next, the next workflow is parallelization. Okay, so this is where Langgraph really shines. Why? Because this parallelization pattern, it runs multiple operations simultaneously. Okay, and then it brings back the results together. Let's go for an example. Let's say you are building some research tool. Okay, let's say you have a company and your company is building some research tool. Okay, now when some user comes and if they ask about some company. Okay, so let's say they are asking about some company. So what you need to do, you want to gather information from multiple sources, right? Let's say there are four different nodes. Okay, and user is asking about your company policies or something. Okay, at node 1, what it will do, let's say it will search for some financial databases. Okay, for some data. At node 2, it can scrape some recent news articles or something. At node 3, it checks some social media analysis or social media comments or anything. Okay, at node 4, it will look for some competitor information. And here, after processing all these four nodes, it will run at the same time. Then there will be aggregator node at the last. If you see this, so there is one node here and there is one node at middle and there is one final node here. Okay, all these nodes, all these three nodes, it will run at same time. So in our example there are four nodes. Okay, all those four nodes, it will run at the same time. Then there is an aggregator node at the last. Okay, it will combine all of this information into some comprehensive report. Okay, finally what you need, so user is asking some company details. Okay, tell about your company. And individual processing is happening in individual nodes. And you want to submit a final answer, right? That final answer will be aggregated from all of these nodes. Okay. So now why it is like much more popular than prompt chaining means, so this is, if you see this, each node it is executing on its own. Okay, so this is very much faster than let's say, so your prompt chaining, what happening here, first one node will be executed, and next another node will be executed, and next another one more node is executed, one after the other, right? But here in parallelization, all the nodes are executing on its own simultaneously. Okay, so that's why this is much faster than this prompt chaining. Okay, because all the processing is happening at one time only, right? So let's say in your prompt chaining, as this is a sequential processing, let's say there are three nodes and each node taking 3 seconds for its processing. So three nodes, 3 into 3, 9 seconds. So 9 seconds to process your prompt chaining. But in your parallelization, again there are three nodes, but this time all the three nodes are working simultaneously. So now all the three nodes is working simultaneously. So now just 3 seconds, right? And maybe zero point 0.5 second or 1 second more for the segregator. Overall, you can complete the entire execution within 3 to 4 seconds if you use this parallelization workflow. See here, there are three nodes in prompt chaining and there are three nodes in parallelization, but prompt chaining is taking 9 seconds to complete. Sorry, prompt chain is taking 9 seconds to complete, but your parallelization is taking only 3 to 4 seconds. So you made your system faster, right? You made your system 3x faster, right? So that's what you are saving some time. Okay, you are optimizing your workflow by using this parallelization technique, right? So going next, you have routing. Okay, so this is also one more workflow pattern. Okay, so routing is nothing but as we discussed it before, there is some conditional branching where your graph makes some intelligent decisions about which path it needs to take. Okay, let's say there is a content moderation system where user submits, let's say user submits some content. Okay, then what the router will do, router analyzes the content, and so router is nothing but one node. See this here, router, this is one more node here. Okay, based upon the user's content, let's say there are three different routes here. Okay, see this, from router there are three different routes here. Okay, let's say if that analysis or if that content is clearly safe, then it will finally process it will process and your output is generated. Okay, and let's say if the content is at like some borderline or something, it needs some more clarification, so it will send to some human moderator. Let's say your first node is your human moderator, this first node. Okay, and let's say if your content is violating some policies, it will reject immediately. Okay, so based upon that decision, it will route into different parts. At first path, it is routing to some human approval. Okay, at second path, it is directly generating the response. Okay, at third path, it is rejecting immediately. Okay, so based upon the routing decision. Okay, so if your use case needs some conditions to be fitted, based upon that conditions, let's say it's a like simple if else block, right? If something happens, then this needs to be executed. If not, this needs to be executed. If not, this needs to be executed. Okay, just like simple if else block. Okay, based upon that routing condition, it will route to different routes. So finally, every routing decision it made, so finally it will go to another one more node and process it, process the information, and does everything, right? So this router is a node, and this call, see this print, this first print, this is a route, this is a node, this is a node, this is a node. Okay, finally this is your complete workflow, right, from start to end, but based upon some condition, based upon some routing logic. Okay, so if your use case needs some routing decision, then go for this routing pattern. Okay, next we have um, the next one is we have orchestrator workflow pattern. Okay, so this is somewhat advanced pattern. Okay, let's say imagine i- there is a project manager, he's coordinating a team of specialists. Okay, there is a project manager, there is a team, obviously, right? Now, so your orchestrator is your project manager. Okay, so let's say your project manager receiving a request like let's say some user is asking, analyze the electric, uh, let's say like analyze the electric vehicle market in Europe. Okay, they are asking simple question. Analyze the electric vehicle market in Europe. Okay, this is your question. This is the user query. Now, what your orchestrator will do means it will break this complex task into multiple subtasks. Okay, this orchestrator, this is your project manager, what he is doing. So he is breaking entire task. What is the task here? Analyzing the electric vehicle market in Europe. Okay. So now your orchestrator, it will break this complex task into multiple subtasks. Let's say the first subtask is the first subtask. Let's say it is assigning to the worker A. Worker is nothing but node A. Okay. So the task of node A is to analyze market size and some trends. Okay. Now the task two is the node two task is research some major players or some competitors and some market share values for them. Okay. And task three or node three, let's say the functionality of task three or node three is to examine the previous results or previous shares or everything. Okay. These products or everything. Now, finally, all these workers doing their own task, okay, specialized in some different tasks, and they work parallelly on their specific task, right? So task A has some work to do, task two, your node two has some work to do, your node three has some work to do. All these nodes, they will work in parallel on their specific task. Okay. Then finally, after working, your orchestrator, it will collect all the reports, okay, all the reports from node A, node B, node C, node D, whatever, how many you have. It will collect all the reports. And finally, there is a synthesizer node. What it will do means it will synthesize them into one comprehensive report. Okay. Your node A is performing some task and coming up with some report. Your node B is performing some task and coming up with some report. Similarly, node C is coming up with some report. Finally, this synthesizer, it will synthesize all of these reports into one report and finally generate the answer. Okay. Okay. So, so if you see this one, so this orchestrator, it is routing to multiple worker nodes. Okay, these, if you see this, this is worker node, this second one, this is another worker node, this is a third another worker node, this these boxes in the middle. Okay, so all these workers, it will process their whatever the assigned task. Okay, it will process the task and results to the synthesizer. Okay, and synthesizer, it combines everything and generates the output. Okay, so this is how your orchestrator workflow look like. So let's say you have a situation, you need to design some complex workflow where where user may give some complex questions. So based upon that questions, you need to process different things. Okay, you need to process, or you, let's say, you need to query your databases for information and also you need to query another database for some policy information. And let's say you also need to go and do some web search for some additional information. Let's say if your task needs multiple steps to perform, then go with orchestrator workflow. Okay, so this workflow, this LLM, it will dynamically, it will divide the task and assign it to your worker nodes. Okay, your worker nodes. Okay, it is just assigning the tasks to different nodes. Okay, you do some, you do something, you do something, and another node you do something. Finally, all the work will be combined. Okay, like you're working in a team, okay, for a project, right? Your project manager, so he is he or she, they are dividing the task into multiple tasks and each task will be assigned to each team member, right? And finally, all your team members, so you will do your work and finally you will push everything to the git or something, and finally everything will be merged, right? Similarly here. Okay, so this is the orchestrator workflow pattern. Okay, next up, finally we have evaluator optimizer pattern. Okay, evaluator optimizer, see this graph on the right side. Okay, so this evaluator optimizer pattern, it's an improvement loop. Okay, it's like an improvement. That means, let's say you are generating you are generating an application where it will do some block generation. Okay, so you are building a block generation application. Okay, with if you are using some evaluator optimizer workflow, you will also get this evaluator node. Okay, so let's say generate you want to build some block generator application with some quality control. Okay, quality control means quality check. Okay, after generating, you want to check the quality of it. Okay, then how? Then you need to go and use the evaluator optimizer pattern. Okay, let's say at first you have a generator node. What it will do, it will create some blocks. Okay, it will create some block post and draft everything. Okay, in that block everything. Okay, and next, you after generating, you have a evaluator node here. Okay, what the evaluator node here it will do means, in your use case, let's say generator node, it is generating a block, and this evaluator node, it will go and check is the grammar correct, or does it match the um, whatever brand you are having. Okay, and the current block is it is SEO optimized. Okay, or else whatever the facts generated, are these true? Okay, or the length is generated, is it appropriate, or it should be short, or should be more? Okay, your evaluator node, it will processing all of this information. Okay, and now after evaluator node, if you want, you can also keep some decision node also. Okay, that decision node, it will score your content. Okay, it will score your response. Okay, let's say you are setting some threshold. Okay, go and approve this content if the quality score is above 8 out of 10. Okay, and if it scores between 5 to 8, again send it to the optimizer node. Let's say you have optimizer node also, which will go and process it once again. Okay, and also if the score is below 5, again you may redirect to the generator node once again. Okay, you may reject that one, and you may redirect to the generator node once again to regenerate once again from the scratch. Okay, that is what your decision node may do. So you have evaluator. First, it will evaluate your content, everything, and there is some decision node. It will make some decisions. So based upon the evaluation score, if the quality score is above 8 out of 10, then it may publish. Or if the score is between 5 to 8 out of 10, it may send to another one more node called optimizer. Okay, where it will optimize your blog. Okay, and if it scores below 5, it will regenerate once again. Okay, see this based upon a decision you are making, you are enhancing your blog. Okay, based upon your decision. Okay, so here directly you are not only generating the LLM answer. Okay, you are also evaluating your LLM response. Okay, so generating in the sense your LLM, your AI LLM, it is going to generate it, right? So in your workflow pattern itself, you are evaluating this response, what the AI is generating, right? See how secure it is. So you are generating and evaluating at one go, right? So if you want, if your application or your use case demands these kind of thing, then you need to go and use evaluator optimizer. Okay, where you need to set some evaluator nodes, some decision nodes, some optimizer nodes, whatever you want. Okay, so these are some of the important workflow patterns. Okay, so like we have like prompt chaining. So if you want to build some sequential chaining or sequential workflow where each step builds upon the previous, then go for prompt chaining. Okay, if you want, if your use case demands simultaneous execution, okay, then you need to go and use parallelization. Okay, if your use case demands intelligent some path selections, then go and use routing. Okay, so if your use case demands coordination of some specialist agent where each agent needs to perform some specific task, then go and use for orchestrator worker. Okay. And then if your use case demands quality improvement, then go and use evaluator optimizer workflow. Okay. So finally, so when you are designing your Langgraph applications, most of the cases you will combine all of these patterns. Okay, or two three patterns. Okay, so you might want your orchestrator workflow to use parallelization. Okay, to run process simultaneously. Okay. And also your use case may also require a router which might route route to different nodes based upon some complex queries. Okay. You might also need prompt chain. Okay. Based upon the routing decisions you made, you may also require some sequential processing. Okay. So whatever. So if you want to use individual workflow, we'll go and use. Okay. If you want, you can also combine all of these approaches at all of these workflows into a single graph. Okay. Right. So the beauty of this line graph is it will give you all the building blocks to implement your use case. Okay. So by using these patterns or these things, so you can build your production ready AI workflows. So nowadays you are hearing this term, burst term, AI agents. Okay, AI is everywhere. AI is replacing jobs. Okay, so the layoffs are happening because of AI. Why the layoffs are happening? Because there are this complex pattern. These are complex workflows. Okay, where AI agents can do everything. It will go to your system. Okay, it will open your application. Okay, it will enter your username password. It will log in through your into your application. Okay, it will do whatever you want. Okay, so your human here is replacing here because of this AI agents, because these AI agents are capable of all of these things. Okay, here there are some complex workflows, there are complex tool calls, there are NCPs. Okay, all are combining together to form a complex pattern, complex workflow. Okay, so moving forward, there is another one more concept called human in the loop. Okay, so these are the human in the loop. This is again something really critical for production systems. Okay, production AI systems, human in the loop. So why means sometimes um, we already know our AI is perfect. Okay, I mean, so AI is powerful, not perfect, right? AI is powerful, but sometimes it's not perfect, right? So let's say in enterprise applications, sometimes, not sometimes, obviously we need human judgment at some critical points, right? In your enterprise applications, okay? You directly don't rely on AI output, right? You're building some applications, you're generating some response, and you can't deploy it directly without human intervention, right? Why? Because AI can make mistakes, right? It may hallucinate, okay? Or it may produce some low quality output, okay? What if we don't check all of these cases, okay? So let's say in some industries like healthcare, some or finance or some legal entities. So these humans, they needs to verify this AI decision because these are some sensitive industries, okay? Healthcare, some finance or legal, okay? If some mistakes happens, then it may ruin a person's career or it may happens to anything. Okay, let's say in healthcare, if the AI decision, let's say if the patient is having cancer, but the AI decision is no, this patient is not having cancer. What if that human not taking some care or what, he may dies, right? So your AI is making mistake here. Okay, it is hallucinating, it is producing some low quality output. Here human must need to verify these AI decisions, right? So before taking actions that is impacting users or systems, human approval is essential in your enterprise grade applications, right? Because and users also they'll trust your system when there is some human, okay? Because human knows everything, right? He have emotion, so he can think in all ways, okay? All, from all corners, but AI can't, right? So that's why human in the loop is very important. And your Langgraph gives you that feature. Okay. So, so in your human in the loop integrate in your human in the loop integration, so there is an interrupt pattern. That means, let's say you built a workflow and your workflow is moving along and it will hits an interrupt point. So you will keep some interrupt point in your workflow. So when your workflow is moving along, when it sees some interrupt point, then what your workflow doing is your workflow completely stops over there when it sees some interrupt point. Okay. And then after stopping, it waits for human to provide some additional input or give some approval before moving forward once again. Okay, your workflow is flowing. That means your workflow is executing. So when it sees interrupt point, it eventually stops and it waits for human approval or human inputs to process. Okay, let's say uh, there is a contract generation system. Okay, let's say you are building some contract generation system. So at first node, AI is making some draft contract. Okay, but before sending it to the client, so there is interrupt point before sending it to the client. Your workflow pauses. Okay. So as it is making contract, it needs human review. So you set a interrupt point, it will stop at that interrupt point. Now your, let's say there is a lawyer or attorney. Okay. He will review that contract and makes some necessary changes and he will approve. Okay, only when your attorney or someone he is approving, then only the workflow continue to send the contract to the client. Let's say your final notes, the task of your final node is to generate that contract to the client, okay, through email or something. But before that, there is a human interruption. Okay, at first node, the enter processing is happened. Your AI, it made a contract, okay, it generated a report and sent, and it is flowing to the next node. And but here there is an interrupt point. Your lawyer or some person, they review that contract, make some necessary changes, and they approved it. Okay, and then only it goes to the final node and send that contract to the client. Okay, so this is what happening. Okay, if you see this diagram, step one to step two. So after step one, it is leading to a pause. Here, there is some human here. Okay, it is taking the human feedback. It will update the state. Okay, and then continues to the step two. Okay, so this workflow works in this way. When there is interrupt point, it will go to the human, and based upon the human feedback, it will process to the next stage, or it may go back to the previous stage, whatever it may be. Okay. And also there are approval gates. Okay. This is like a checkpoint. Okay. So you can only proceed if you have some approval. If you see this graph, okay, if you see this graph, so LLM is generating some response and there is a human in the loop. Okay. So there is interrupt point. So here the role of human is to approve or reject. Okay. If it is approved, it will go to some node for some processing. If they reject it, it will go to another node for processing. Okay. So this is one more case, the approval gates. And also you may also include some feedback loop. Okay. Sometimes humans don't just want to approve or reject. They sometimes they want to guide and correct the AI, right? Okay. If you reject it, what happens? Your entire workflow may stops working, right? But sometimes you want to guide your LLM to correct their response. Okay. So at that time, your feedback loop actually helps in this case. Okay. Let's say um, there is an AI code review system. Okay. AI code review system. Okay. Now, at first stage, LLM generating something. Okay. And LLM generating some code, something. Okay. And then there is a human interruption point. Human, what at this stage human reviews it, right? And then he can choose either approve or reject. But okay, but also human wants here something more than approval or reject in this case. Okay, let's say um AI is suggesting some code at starting. Okay, AI is generating some code, and now human developer he is reviewing that code, and then let's say he is giving this message like, okay, this optimization is good, but I don't want this algorithm. Go and use this different algorithm. Okay, so AI generated some code, but now human is telling, okay, this is good, but go and use some different algorithm. Then what your workflow does is it takes that feedback, it takes that human feedback in the state. So feedback in the sense you input or output, everything will be maintained by a state. Okay, it will update the state. Okay, whatever the feedback human is giving, it will be updated in the state and it will go back. AI implement that specific correction whatever human is telling, and finally it will process that correction once again, and once again it comes to the human developer. And now if the human developer says, yeah, I'm satisfied, then what he will do, he will approve it. Okay. If not, if he wants, he may suggest some additional optimizations, he may give some additional feedbacks, or not, or he may directly reject it. Okay. So here the key benefit here is the gradual automation. Okay. First we are starting with human involvement. Okay. So you are starting with LLM response, and then there is a human involvement. Okay. So entirely what it is doing. So your AI is improving based upon your human feedback, and it is gaining some confidence, right? So at some stages, it's very important because you need some domain experts to review the answer, to review the AI answer. It is very most important, okay, before sending it to the final stage. Okay, so this is reducing the human involvement. Okay, so your AI is processing everything, and after processing only, it is coming to the human, and human quickly checks. Okay, this is the output. Okay, is this good or not? Okay, if it needs some suggestions, that human gives some feedback in the form of text, and again LLM will generate response based upon the human feedback. Okay, and that's how your AI is improving. Okay, you are involving a person here, so your Langgraph gives you that future of human in the loop. Okay, so when you're building your Langgraph application, you can set these interruption points. Okay, in your code you can set up some interruption points. Okay, so at certain needs, if you go and implement some interruption points, it will stop at that point. Okay. So your execution passes automatically at that point. And then system wait for external output from human. Okay. And then it will process once again. So that is how the human in the loop works. So okay. So before going to the practical implementation, let's discuss this last theoretical topic. Okay, this is a somewhat huge topic. Okay, retrieval augmented generation RAG, which is powered by Langgraph. Okay, you already heard about RAG, so you are hearing what is RAG, what are generative AI applications. The generative AI application is sometimes nothing but a RAG. Okay, now we will discuss RAG for Langgraph. Okay, how RAG is useful for Langgraph. Okay, so you're already familiar with basic RAG, right? What it will do. So there will be human query, and it will retrieve relevant documents, and then it will pass it to the LLM. Okay, that's how your simple RAG works. Based upon the human query, it will retrieve some documents from vector database and generate answer by passing them to LLM. Okay, so this is how your simple RAG works. But this is basic rack, right? Sometimes your basic rack is not good enough for production system because your production applications, those are very complex, right? Sometimes it needs some it needs to query some documents from some databases. Okay, sometimes it needs to handle some complex queries which may require some multiple retrieval steps. Okay, sometimes it needs to process information from different angle. Okay, so there will be some complex workflows, right? So here, this is where the Langgraph comes in. Okay, if you see, your Langgraph gives you some RAG strategies that may go beyond some simple retrieval. So your simple RAG, it will give you simple retrieval, but your Langgraph gives you something bigger than that. Okay, so why? Because why something bigger than that means your Langgraph has cyclic groups, your Langgraph has human in the loop, some bigger features. Okay, and also you may integrate your tool calls. Okay, to your nodes, you can set up some tool calls. You can call your MCP server. So there are many features built in Langgraph, many things in Langgraph that will um, be fitted to your simple RAG, and that simple RAG becomes complex RAG, which is capable of solving your complex problems, right? So how? we are going to explore three advanced drag patterns. So basically, I think you might heard about just simple drag only, right? Now we will see some advanced drag patterns. Okay. In that, the first one is the agentic drag. Okay, agentic RAG. So here where the AI agent decides when and how to retrieve. Okay, RAG is basically means retrieval augmented generation, right? So it is retrieving some information from vector databases. Okay, that's the simple RAG. Okay, based upon the human query, it will go and retrieve the documents. But in agentic RAG, AI agent decide when and when, what, and how to retrieve the relevant documents. Okay, so whatever I'm telling, for someone, it may be first time. I mean, you might have like listening for the first time. Okay, but this is a simple thing. Like you are, I think you might have got idea from your previous classes also how the RAG application works on that. Okay, I hope so because these are some advanced topics where you require previous knowledge of how the simple RAG works, how the generative AI application looks like. Okay, what are the components inside generative AI application? Then only if you know those things, you can understand these things easily. Okay, I think from your past classes, from your previous field. So other mentors, they already discussed about basic RAG, how the LAN chain looks like, how the generator application look like, what are vector DB and everything. Okay. So that's why I'm going directly to the advanced topics right now. So in that we have agentic RAG. Here AI agent decides when and how to retrieve. Okay. So and also we have something called as corrective RAG and also adaptive RAG, three different RAG strategies. Okay. So these are not just some theoretical concepts. These are some patterns using in the production systems. So these patterns are using in your companies. Okay, organizations are using these patterns: agentic RAG, corrective RAG, adaptive RAG. Okay, because they want to build some serious RAG applications, some complex RAG applications where they need to solve um, big issues. Okay, some complex issues, and they want to save funding for their organization or something, whatever it may be. They want to automate the large process. Okay, that's why they need this advanced RAG patterns, agentic, corrective, and adaptive RAG. Now let's discuss what are these patterns, how they look like, what they do. Okay, so first we have agentic RAG. So we know in traditional RAG you always retrieve directly. So your query, it will triggers a retrieval step and it will generate some output, right? But let's think in this way. Okay, what if there is some AI agent in between? Okay, so after getting the user question, there is an AI agent. Okay, your AI agent can reason about your query. By seeing the query, your AI agent, it will make some decisions. Okay, so based upon the user query, whether the retrieval is needed or not. Okay, let's say, let's discuss this with some example. Let's say user is asking this question: what is the capital of France? Okay, we already know it's Paris. Okay, but query one, this is the query one. Okay, let's say user is asking what's the capital of France. Now there is AI agent there. Okay, here AI agent thinking, okay, this is okay, this is simple question, right? So AI agent thinks, okay, I already know this. I already know the answer for this question because these people or these developers, they already trained me with these things. Okay, this is a simple thing. Okay, some general knowledge thing. So these humans, they already trained me with this, all of this data. So I already know the answer for this question. So it thinks, okay, no retrieval is needed. What it will do, your AI agent, it will generate the answer directly. Okay, because it already having the knowledge of that one. Okay, so user is asking capital of France, and your AI agent generating answer directly, it's Paris. Okay, and now let's say user 2, he is asking what is your company's quarter 4 2024 or 2025 earnings. So this is 2025, right? So let's say some user is coming to your AI application and they're asking what is your company's quarter 3 2025 savings or earnings, every anything. Okay, so now there is an AI agent, right? Now it is thinking, okay, this query is related to the company specific, okay, and it also thinks, okay, I don't have information related to this company. So what it needs to do, it will think like, okay, I need to retrieve from the database. Okay, then what your AI agent do? It will retrieve from the company database and it will generate answer with some retrieved context. Okay, so based upon that query, once again, this time it is directly not generating the response. Okay, it is retrieving from the database and generating response based upon that, right? Next, let's say if some user is coming and they are asking, explain about quantum computing. Okay, so now the AI thinking once again, your AI agent thinking once again, like, okay, I know. So this quantum computing, so this is a like future coming research. Okay, so this is the future thing, so we don't clearly have much research on this quantum computing as so far now. So it what your AI agent thinks here is, okay, I can explain the basics, but I need some more information to give this user the more accurate answer. So what it will do, first it will generate some response, and also it will do some web search. It will go to some Wikipedia, or it will go to some articles. Okay, it will go to your browser and it will do some search and brings the recent developments. Okay, and then based upon the um, based upon the data it is having, and also based upon the context it is retrieved from the web search, it will combine all of those response. Okay, it combine its own knowledge with the fresh information it is getting from the web. It will combine everything and it will give the comprehensive answer. So see this, your AI agent making some intelligent decisions here in your advanced RAG. So RAG is basically retrieving some context. Okay, so if there is AI agent over here, if there is no AI agents, what it will do, after getting query, it will go to your vector database, it will query the information. So whether the query is relevant or irrelevant, whatever it may be. But here, if there is AI agent in your rack, it will think, it will make analysis on that query. If it's a straightforward answer, it will answer based upon its trained data. Or if it requires some additional information, it will go to web search, or else it requires information from the databases. It will query those databases and find some relevant information. Okay. So here the key thing is, every query, not sorry, every query don't require retrieval. Only some queries require retrieval, right? So based upon the AI agent analysis, it is making decision whether I need to retrieve, or whether I need to give the direct answer, or whether I need to go to the web search and do some searching and all. Okay, so this is what the AI agent gives you. So it is giving the reasoning capability. So your AI agent is actually thinking about whether it is having some existing knowledge or not. Okay, and then if the knowledge is not sufficient, it may go to web search and it will get some relevant context, or else maybe it will do some vector search for some relevant information. Okay, after retrieval, what does the AI agent does? So it will generate a comprehensive report or comprehensive answer and give it to the human. Okay, so this is how your agentic RAG works. So if you see this graph, so it's, there is agent node. Okay, this is your agent node. Okay, here agent node, it is deciding should I retrieve or not. Okay, so there is some conditional edge. If you see this diamond symbol, so this is a conditional edge. Okay, it is thinking should I retrieve or not. Okay, if no, what it will do, if no, it will go to the end stage. At end stage, it will continue to generate the answer directly. If yes, if it needs to retrieval, if it thinks I need to retrieve some information, if yes, it will go to tool node. Okay, so your tool node, it will goes to tool node. Your tool node, what it will do, it may rewrite some query if needed, and actually it will retrieve some information. If there are some vector databases, it will retrieve information from that vector databases. Or not, if you need to perform some calculation, it will do. It may do. Okay. After retrieving, again there is one more node checking relevance. Okay, there is some conditional edge after retrieving. So your AI agent, it is thinking once again, are the retrieved documents are relevant or not. Okay, if yes, if they are relevant, they are generating the final answer. Okay, if the documents are not relevant, so if you see this line, it is again going back to the first stage agent node. Okay, it again goes back and it will rewrite it once again. Okay, so this is the loop. Okay, from here to here again it's going back, so it is the loop. So that's the self correction actually happening. Okay, if the retrieval quality, so here it tool node, it is retrieving something, and if the retrieval quality is poor, then it tries again, it go backs and tries again by regenerating once again. See this, how your agentic RAG is working. So based upon the condition, if it's need direct answer, it may go to this end stage and give direct answer. If it needs some retrieval, it will go to tool node, and from your tools, it will pick what tool I need, and based upon the tool node, it will retrieve the documents, and it also checking this relevance. Okay, if the retrieved documents are relevant or not. If not, it is going back once again. If yes, it is generating the final answer. See this, how it is working. So there is self correction also happening here. Okay, not only the retrieval part. Okay, there is also self correction. So your qualities, your AI quality is improving here. Okay, AI generated responses improving here by using this agentic RAG. Okay, there is no need of human intervention. Okay, AI only generating the answer, AI only checking the relevance, it is scoring it the relevance, and based upon the relevant score, it is rewriting it once again. If it is good, it is generating the final answer. See how many things are happening inside this simple workflow. Okay, it is retrieving, it is making decisions, and then it is retrieving, and then it is taking some relevance, and finally generating the response. Okay, generation plus correction happening in a single workflow. Okay, so this is what your agentic rack is capable of. Okay, next, going forward, there is a corrective rack. Okay, this corrective rack, this is one of my favorite pattern. Why? Because it is addressing a massive problem in your basic rack systems. Okay, for example, um, let's say your traditional rack system, it is generating some response. Okay, but there may be some questions. Okay, the answer, it is retrieved from the vector database, so we might have this question: is this answer relevant? Is this answer, whatever it is generated, is this relevant to the user question or not? This is the biggest question. Okay, and also there is one more question: are this the retrieved documents, are this relevant, or are this outdated? So there may be one more question like this. Okay, and there might be another one more question, let's say, like what if this document actually don't answers the user's question? Okay, so there might be some n more questions, so all these questions may arise for us, right? So what if the documents are old, they are outdated? What if your LLM can't able to fetch the relevant documents, okay, relevant information? Okay, so what if the answer it is fetched, it is not much accurate? So these may be some problems in your rack systems, right? So with corrective rack, actually what happening here is the answer it is retrieved, it actually evaluates and corrects it. Okay, so after retrieval, the system immediately it will evaluate. That means, so if you see this, there is a grade node after retrieval node, there is a grade node. Okay, so these grade nodes, this is checking, are this document actually relevant and useful? It is thinking in that way. Okay, let's say user is asking about 2025 recently launched iPhone 17 Pro features. Okay, user came to your application, they're asking what's the iPhone 17 Pro Max features. Okay, and now the system, what the system will do, it will retrieve some documents. That means it will retrieve information from the vector database, and then it will evaluate each document. So your grader node, it is thinking, okay, the user is asking about 2025 iPhone futures, so it is thinking, okay, is this really the retrieved information, is it really about 2025 iPhone 17 Pro? or is it about 2024 iPhone? So is it detailed enough? Okay, it is thinking in this way, this grader node. Okay, and then so if evaluation shows poor quality, then it will automatically trigger another retrieval node. Okay, so so if you have some poor quality, then what it will do? What that means? So your internal knowledge base doesn't have the good information. So let's say your database is having information until 2024 iPhone, but your database is not updated with 2025 latest iPhone details and all. So what it will do? There is one more node here. Okay, what it will do means it will go to web search as we discussed before. There might be another node. It goes to web search. It will find the latest information about 2025 iPhone futures, and it will I mean scrape that data from that web and everything, and finally it will generate the answer, give it to the user, right? So how it knows whether it needs to go to the web search or not? By grading only, right? So after grading the retrieved context, and with that grading score, it is deciding, okay, whether it needs some additional search or not. Okay, so basically like some confidence scoring is happening. Okay, each retrieval document it's getting some confidence score. Okay, based upon that confidence score, it is deciding what it needs to do, whether it needs to do some additional search or whether it needs to generate the answer. Okay, or for example, at no case, if the answer is not relevant, if the score quality is very low, it may also go back to the retrieval node once again. It will generate the content from the beginning. Okay. See here, every stage here there is no human. Okay, no human needed. The system automatically it is correcting the poor retrievals. Okay, based upon the quality or confidence score, it is performing some other new task, right? So this is the self-correcting RAG. So it will retrieve the document, it will correct the documents, okay, by some confidence score or something, and based upon that, it will finally generate the answer or go back to the first stage once again, right? So everything is happening without human intervention. So finally, we have adaptive RAG. Okay, so sometimes, um, let's say there might be, let's say you have a pharmaceutical company, you have an AI application. Users can come to your application and they can ask some relevant questions related to your pharmaceutical company, or some users may come to your application and they may ask some irrelevant questions. Okay, so your application related to your pharmaceutics, but they may ask some different questions. Okay, it is possible, right? So they may think like it's a like general chatbot, and what if they ask some irrelevant question? Okay, so your AI needs to be capable of treating all the queries. Okay, it needs to read all the queries, and based upon the user query, it needs to process whatever it may be. So whether it needs to process the information from web or whether it needs to process the information from its databases, anything. Okay, let's say, let's think about an example. Okay, let's say there are three different queries. Okay, the first query is what is photosynthesis? Okay, and then there is another one more question, like let's say compare the revenue growth of Tesla, Ford, GM. These are like automobile companies, we know, right? Okay, another question is um, some relevant question. Let's say I think there was something. So they know your company launched some product, and the user is asking, okay, there is something your product is calling. I mean, I want to just know your product details, your product savings from your last month or last year or something. Okay, some user is asking about photosynthesis, which is some general question. Some user is coming and asking about what's the revenue growth of these companies, Tesla, Ford, whatever the companies may be. Okay, so another user they are asking about your actual product. Okay, now based upon these queries, yours, uh, I mean, the strategy, whatever the strategy may be, it will adapt based on the query type. Okay. First, whenever the query is coming, the system first analyzes the query. Okay. First, it will think, is it a simple query or complex query? And then it will think about, is it clear or not? Okay. And also it thinks about, does it need recent data or not? And also it thinks about, is this query about the AI application the user built, or this is just the query which is irrelevant to this application. Okay, it will think all of these possible ways. Okay, and then what it will do means, it will route queries to most appropriate retrieval method. That means after checking the query, it will think like, so does it require direct vector search? Okay, if it requires some vector search, it will direct it to the vector database. Okay. If it requires some multiple retrievals, let's say like first it needs to fetch some data from one database, and next it also need to fetch data from another database, and also it needs to perform some calculations. Let's say if it is complex query, it needs to perform these multiple steps. It will route to the different route. Okay. And then if the query is some general query, if it is not related to the current AI application, what it will do? It will do some web search, and then it will give the relevant response. Okay. See this based upon a simple query, your AI system, it is not saying no. So if the answer is available in their system, it will go and fetch that information. If that answer is not available in their system, it will go and call the tool nodes. Okay. So here the query analysis is happening. Okay. So before before the other processing, your query analysis is happening. That what your adaptive RAG gives. Okay. The query analysis is the core feature here. Okay. And next, so based upon the human query, your adaptive RAG, it will choose the right tool for each query. Okay. So if you look at this diagram, okay, if you see this query analysis, so it is splitting the query into different processing path. If you see this, the top, this one, the top arrow, it is, if it is related to some index, if it is related to this tool, so it is routing to this path. Okay. If it is unrelated to index, then it is doing some web search, and finally generating the answer. Okay. If you want, you can also add some more routes based upon the user query. Okay. Based upon the user query, you are adding some routes here. Okay. So over time, so what your system does means, it will learn. Okay. So it will learn, so these type of query, what I need to do for these types of queries. Okay. So totally it have RAG plus self reflection. If you see this, for example, if it's route to this stage, to this first route, here there is a RAG plus self reflection. That means, so it is there is a retrieval node, it is retrieving some information, and then it is creating some information, and if the documents are relevant, then it is generating the node, and also it is checking if the answer is hallucinated or not. If no, again it is checking if this answer, if the correct, if the answer which is retrieved is it related to the context or not. If yes, it is generating. If no, it is going back once again. If you see this RAG to self reflection, this is corrective RAG. See this is corrective RAG. There is a generate node, it is checking the relevance of the documents. Okay. If it is not, it is going back once again. If it is yes, and it is generating the output. So your adaptive RAG is a combination of query analysis and corrective RAG. So this is a corrective RAG, but in your corrective RAG, there is no query analysis. But here you have query analysis and correctiveness. Okay, both are combined here in your adaptive RAG. So that's why this is widely used for some complex applications. Okay, so what it is doing finally? So they are not just retrieving and generating. So they are intelligently, they are orchestrating different strategies based upon query, based upon the retrieval documents. It is making different strategies and different decisions. Okay. So that's what your complex use case can be solved. Okay. So we covered three RAG patterns for now. Agentic RAG. Here in agentic RAG, agent decides if it needs to retrieve or not to retrieve. Okay, in a corrective RAG, system evaluates and self corrects some of the bad retrievals. Okay, it will evaluate and correct. Okay, your adaptive RAG is a combination of query analysis and corrective RAG. Okay, different strategies for different query types. Okay, so your complex systems combine all of these three approaches once again. Okay, your adaptive RAG. Okay, it will routes your queries to different strategies. Okay, where each strategy might use some agentic RAG for some intelligent retrieval decisions. Okay, and your corrective RAG, it will provide you some quality control. Okay, it will grade your response and it will self-correct it. Right. So if you combine these three approach, if you combine these three, adaptive, corrective, and agentic RAG, you can build a much more complex application. Okay. So this Langgraph, it is making possible, okay, to build this powerful workflow orchestrations. Okay. So this is all about, um, let's say, like different rack patterns. You might have heard about simple RAG only, right? But this is something more complex. If you want to build some more complex applications, you need to know about this agentic RAG, corrective RAG, and adaptive RAG. Okay. So now let's move to some use case. Okay. Now until here we discussed about some theory only, right? So we discussed about different workflow patterns, different rack patterns, right? Now we'll see one practical example for how the human in the loop actually works. Okay, so we are going to build a simple weather assistant, okay, that can answer weather related queries, okay, using the tools. Okay, this is what we are going to see now. So in this application, in this AI application, we are adding human supervision, human in the loop checkpoints to decide human can approve or reject, or they may provide some additional feedback or some changes to the retrieval context. Okay. So now we are going to see an example that can have human in the loop. So as this is a boot camp, so we have limited time. I already made this workbook. So I'll walk through each and every block and I'll try to explain what the each block is doing, what the each code line is doing. Okay. So first, um, first what it is doing is from .env import .env. So this lines import OS from langchain grok import lang chat grok. So these are some import statement actually. Okay, what's happening here is first at line 1, 2. So these two lines, we are loading environment variable from .env file. So there will be some environment file. So where you will store all of your API keys here. Okay. Now I need to call this API keys here. Why I need to call this API keys here? Because we need LLM to generate response, right? So in order to connect to my LLM, so I need API keys. Okay. There are different platforms where we make it our API keys. There is a Grok platforms. That's a fast inference engine where some open source LLM models are available. We can connect with those LLMs directly with this Grok API key. Okay. And also if you want to connect with the OpenAI, so you can directly go to OpenAI platform and you can generate API key over here, OpenAI key. Okay, if you want to trace your project, your LangChain project, then you can connect to the Langsmith. Okay, Langsmith is basically helps you to trace, debug your LangChain applications. Okay, and for now we need only this, like we need this Grok API key, okay, and LangChain API key. So these are some different API keys we'll show in this .env. Okay, but so while you are building, don't copy this API keys. You need to generate your own API keys. Okay, you need to go to this Grok platform to get this Grok API key, or else you need to go to OpenAI platform to get your OpenAI key. Okay, so these first two lines, it is loading environment variables from this .env file. Okay, so this is the place where we store sensitive information like API keys. Okay, We will never hard code API keys in our code. Okay. And next, line 3 and 4, we are importing OS, okay, to access this environment variables, okay. And this chart graph from langchain graph, we are importing chart graph, okay. So this is our LLM provider. Grok is LLM provider, okay. If you go to browser and search for Grok, let's see, I'll go to browser. If you search for Grok, so this is goofy. See, this Grok delivers fast, low-cost inference that doesn't take when things get real. So it is a open source LLM provider. Okay, so it has different models. See, it has models from OpenAI, it has models from Google, Anthropic, Microsoft. Okay, and Grok has its own model, and it has models from Amazon, Perplexity, Mistral, Together AI. Okay, so we are connecting LLM model through this graph, okay, through this chart graph, okay. And next up, so here we are setting our API key, okay. So we set the API key from environment variables. So first we are importing our environment, and then we are setting the environment variable, okay. Inside .env we have different API keys, right? So here I want only Grok API key. So os.environ. So I'm getting Grok API key from .env, okay. And next, so here chart graph. See, if you see this chart graph, model equals to Qwen 332 billion. Okay. So here we are initializing our language model. Okay. We imported chart graph, and inside chart graph, we are passing our model name. Okay. So with the use of this API key, it will go to Grok platform and it will connect to this model. Okay. What's my model? It's a Qwen 332 billion parameter. It's a 32 billion parameter model from Qwen. Okay. So this pen, it is powerful and efficient for our use case. Okay. Now, so now we are doing some simple tests. So this chart graph, this model is saved inside this LLM. Okay. Now we are doing some simple tests. We are invoking LLM.invoke. Okay. Here I'm just passing hello message. Okay. Just to verify if everything is working or not. Okay. I'll just show you the result response. I'm executing this block. You see this? Okay. First AI message, it is thinking, okay, the user sent hello, then it is thinking, I should respond in a friendly and welcoming manner. Okay, it is thinking, okay, maybe ask, how can I assist them today? Or keep it open ended to encourage them to share what they need help with. Okay, it is thinking. So, this is all AI thinking. Okay, and if you see this, this is the response from the AI after thinking. Okay, this is the response. I passed hello and I'm getting hello. How can I assist you today? Okay, with some emoji. Okay, so this is the LLM response. So these are all this AI thinking, this additional arguments, some this is these are all some metadata. Okay, some metadata information. So if you see this, there is a token usage. So it took 67 tokens. Okay, and total tokens 76. Okay, prompt tokens 9. Okay, response tokens are 67. Okay, the completion time is 0.16 seconds, the prompt time. Okay, these are all some metadata, okay, which this model is generating. Okay, but now we are only interested with this response. Okay, so I passed hello and I'm getting hello, how can I assist you today? Okay, this is the AI response, right? Now going forward, I created some custom tools. Okay, these are some tools. There are three different tools here. Okay, I already told you. So this is a weather assistant example where user may pass some query. They may ask uh, about some temperatures, or they may ask about humidity, or the user may ask about some forecast information. Okay, so there are these are three different tools. Okay, let's see this first tool, get temperature. Okay, so this is our first tool, get temperature. Let's try to understand this tool now. Okay, so this function, it gets, okay, it is taking city over here. Okay, so when the user passes some city, then this function gets temperature for that city. Okay, right? It takes city and unit also. So unit is Celsius here. By default, it is Celsius. If user passes some unit, it will take, or else default it will treat as Celsius. Okay. Now this string, this arrow mark and this str, it defines, it actually means it is returning a string. Okay. The input here is city and unit, and what it is returning is string of response. Okay, string. The response in the form of string, and this is some doc string. Okay, if you see this is a doc string. This is very crucial for LLM applications. Why? Because this doc string actually tells your LLM what this function does. That means some description about this function. Okay, so by this description, your LLM decides whether it needs to use this tool or not. Okay, it reads the description. What is the description? So get the current temperature for a city. Let's say if the user is asking temperature for some specific city, it will read this description. Okay, this tool is meant for getting the temperature, and then it will invoke this tool. Okay, based upon the description. Okay, now so after this, there is some simulated data. Okay, so in a real applications, so this would be a weather API call. Okay, for a demo purpose, I just used a dictionary with some hard coded temperature values. Okay, some for some major five of the cities: New York, London, Tokyo, Paris, and Sydney. So I'm just hard coded in a dictionary for now. But in real world applications, we might have weather API. Okay, so if user go and ask what's the temperature for this city, it will trigger that weather API, and it will fetch us the information from that API. Okay.
Yeah.
Next, if you see this logic, so after getting the temperature, after reading the temperature, so if the temperature is in Fahrenheit, okay, then if the user wants to convert it into like sorry, if the fetched information is Fahrenheit, and if you want to convert it to Celsius, then this logic happens. The temperature into 9 by 5 plus 32. So this is logic for converting Fahrenheit to Celsius. Okay, and finally, so if it is Fahrenheit, it is converting using this formula. If not, it is returning a nicely formatted string, the temperature in. Okay, so this is city.title. So it will replace the city with the retrieved city, and this temperature will be replaced with this retrieved temperature. Okay, it is returning the nicely formatted string. And similarly, there is one more function, get humidity. Okay, so this also, so it will get the current humidity level for a city. Okay, so this is again very similar structure to the first tool, but this one it will get the humidity instead of temperature. See this, it is taking the city, but here we have humidity levels. Okay, again this is hard coded values. Okay, and finally, based upon the city, and if the user wants to know the New York humidity levels, so it will fetch that information from this dictionary and it will print over here. Again, it is returning a string. Similarly, we have forecast. Okay, it is taking city and days, these two parameters, and returning a string of response. Again, there is some hard coded list where there are some conditions. Okay, and that will be printed. Finally, so we have tools. There is a list. This is a list of tools. So get temperature, get humidity, get forecast. These are our tools. Okay. Now we put all these three functions into a single list. Okay. Now this list will be bounded to a LLM. If you see this LLM with tools, LLM dot. So what is your LLM? So this is your LLM. Okay. Your chart graph, your model, Quen. So your Quen is your LLM. So now I am binding LLM with tools using this bind parameter. Okay, bind tools. Okay, using this bind tools function, I'm passing my tools. So this is my tools. I'm passing these tools. So now what I'm doing here, I'm giving LLM ability to call these functions, call these tools whenever necessary. Okay, so I binded these tools now. So this bind tools function, it will take our regular LLM and then it will transforms it into a tool-based agent. Okay. Now this LLM is a tool-based agent. So now what happens behind the scenes is, so now LLM is now aware of your three tools, whatever you develop. Okay. When when the user sends a message, it will decide, okay, if it needs to use it this tool or not. Okay. It will choose to utilize this tool if needed. Okay, if not, it won't call this tool call. Okay, if the query is not relevant to this tool calls. Okay, now I'm running these functions. Okay, see this. Now my LLM is binded with these tools. Now let's work with Langgraph, building Langgraph. Okay. Now these are all import statements you have. So this is ipython.display. So we are importing image display. So this image display, so it is useful to display our graph, our lang graph. Okay. And then there is a memory saver. Okay. From lang graph, from checkpoint and inside memory, we have memory saver. Okay. So this memory saver, this saves checkpoints of our graph state. Okay, at each and every state, it will save the checkpoint. Checkpoint means we know it will store information until that stage. Okay, so this is essentially we need this for human in the loop. Okay, and now we have something called as message state. From langgraph.graph, we are importing this message state. Okay, so this message state. This is pre-built Langgraph state schema, okay, for chart-based applications. So we already discussed about state, how the information is flowing across the workflow using this state, okay. So now, if we want, we can implement our own state. If not, we can use this pre-built state, pre-built message state, already available in the message, I mean, Langgraph, okay. So now I'm also from LangGraph, I'm also importing start and state graph. Okay, start means your start node. Okay, state graph means your core graph. I mean your entire graph building component, your state graph. Okay. So after you building your entire workflow, you need to keep your workflow in, I mean you need to integrate state into your workflow. So that's why you need the state graph. Okay. Next, we are also importing from Langgraph.prebuild. We are importing tool conditions and tool node. Okay. So again, these are some pre-built utilities for handling tool calls. Okay. So we know we have three different tools, right? So we already integrated our tools for LLMs, right? We already binded our tools. Now we need to include those tools in our graph, right? That's why I need this tool conditions and tool node. These are pre-built utilities. Okay. And now I also importing from LangChain core messages. I'm also importing AI message, human message, and system message. Okay. So these are some message types I need. Okay. AI message means AI generated message. Human message means our response. System message means some prompt message or something. Okay. Now if you see this, so we already import system message. Now, so now I'm passing some information, some prompt to my system message. Okay. See this. If you see this content, you are a helpful weather assistant that provides accurate weather information for cities. This is nothing but our prompt. We are specifying our prompt inside this system message. Okay. When you go to ChatGPT, you'll give the prompt in this way, right? So you are a helpful weather assistant. So you need to provide accurate weather information for cities. Or else, if you are preparing some interview, you will ask the question like, now, let's say you are an expert interviewer. So who is familiar with these topics and you need to interview me. So you'll give some description, right? You'll give some prompt, right? That prompt needs to be given in this way inside the system message. Okay. And next step. So this is our node definition. So the name of my function here is assistant. Okay. This is my node. Okay. The name of my node is assistant. Okay. So this is where the core logic happens inside this node. Okay. Let us see this node. Okay. First, inside this node, it is I need to pass my state variable. Okay, always remember we need to pass state variable to all of our nodes. Okay, so our nodes needs to be capable of fetching the I mean capable of knowing the context, right? Where the context is saving, where the input and output is saving, it is saving inside the state, right? So we need to pass the state variable to our node definition. Okay, so this is my node. I'm passing the state. State is nothing but the message state, which is the pre-built state schema, which is available in LangGraph. Okay, I'm passing that state over here. Okay, now this state is capable of storing AI messages, system messages, whatever. Okay, and then after getting the state, it will invoke. If you see this, this is the LLM with tools. This is our LLM, which is binded with tools. Okay, whatever the system message will be, it will be passed over here. So see this, if you see this, LLM with tools dot invoke, it is invoking the LLM with some system message and state of messages. Okay, so we are invoking the LLM by passing the system message. I'm passing the system message, and also I'm passing state of messages. Okay, inside our state variable there is something called as messages. Okay, it is predefined, it is pre-built. Okay, you no need to build this. Okay, inside state already messages variable is, it's already defined. Okay, so we are invoking our LLM with system message, and I'm also passing state. What does the state stores? The the human input or AI input, whatever it may be. Okay, so I'm invoking my LLM now here. Okay, this is my return function. Okay, for my node. Okay, when this node is executed, it needs to invoke the LLM with system message and state of, it needs to take the state messages. Okay, and now we are building the graph now. Okay, so you may ask me one question, why we need to return like this way? Okay, in basically in Langgraph, your node returns state updates. Okay, you need to remember this point. Each node in Langgraph, it will return some state updates. So whatever the information it is fetching or whatever analysis it is making, it will I mean, let's say if your node performs some analysis, it wrote, I mean, some context, it retrieved some context, and now that context will be stored inside the state only. Okay, whatever the LLM response, it will go and stay inside the state messages. That's why this is very important. Okay, your Langgraph, your Langgraph node always return the state messages because the information from your LLM is stored in your state. That's why you need to return the state updates. Okay. Now, this graph, building the graph, state graph of message state. So if you see this now, this state graph, so it is initialized with this message state. Okay. So we already discussed it. This message state, it is a pre-built state schema that has a message field inside. Okay, which is a list of messages. That's why if you see this, we use it in this way, state of messages. Okay, our state is nothing but the message state, so it is already having a pre-built state schema which has a messages field inside. So this messages fields is in the form of list. That's why you need to write in this way, state list of messages. Okay, so now I'm passing my message state, entire state, to my state graph. Okay, so this is like a graph builder. Okay, it will build the graph right now. I mean, this graph builder in the sense, after um, I mean, after creating your state, after creating your nodes, after creating your tools, everything needs to be integrated into one common functionality, some common builder, right? Everything needs to be executed at one go, right? That's why we need this builder. So here the builder is nothing but the state graph. Okay, and now our builder is ready. Now we need to define our nodes. Okay, so we need to add nodes in our graph. Okay, so our first node is assistant. Let's, you see this, this is assistant node. Okay, our first node is assistant. We need to define our nodes. So inside builder, there is some function called add node. Okay, builder dot add node of assistant, come assistant. So this assistant is name of the node. So my name of the node is assistant, and for this node, what is the function? Assistant. So this is my function. Name of the function is assistant. Let's say this is assistant 2, so I'll pass assistant 2 over here. But the name of the node is assistant only. But the function here is assistant 2. So, but here in this case, my function is assistant and my name is assistant. Okay. Or else I can give the new name over here. Instead of assistant, I can say weather assistant. Whatever name I can give. Weather assistant. Okay. Anything I can specify the name. Okay. And also, um, I'm also creating another one more node. Okay, which is our tools node. Okay, our node 1 is our assistant and node 2 is tools. Okay, again inside the name of the node is tools node. Okay, and Here, if you see this, we imported the tool nodes. Okay, we imported tool nodes over here, tool node from Langgraph.prebuild. So inside this tool node, we are passing our tools. Okay, if you see this, these are our tool. This is our tools variable. Inside our tools variable, we have all of our tools. Right, we are passing these tools to this tool node. Okay, so so this tool node, it will execute the tool calls. Okay. When the assistant returns a tool call, then this node actually, it runs the function and returns the results. Okay. Where the function is available for this tool. So you see this tool node of tools. It will go here, tool node of tools. If it wants to trigger get temperature, and then it will go here and it will execute this get temperature tool. Okay, this is how it works. So we need to specify our tools as a node in our graph. Okay, inside this tool node, and then now our two nodes are ready, assistant and tool. Now what we need to do, we need to define our edges. So every node is connected with the edge, right? So again, inside builder there is a function called add edge. Okay, my first edge is from start. So in my grand graph, my first node is start, right? From start to assistant, I'm creating a first edge. Okay, and then I'm adding some conditional edges. So if you want to add some conditional edges, you need to use this add conditional edges. So inside this conditional edges, I'm passing two things. So first is my conditional edge, from where to where, from my assistant node to tools condition node. Okay, so why this is additional edge? Because every time we no need to call the tools, right? Based upon the query only, we need to call these tools. So that's why this is a conditional edge. Okay, based upon the query, it needs to route to this tool calls now. That's why. Okay, so now, so again, this tools condition, this is a pre-built function which check this condition automatically. So this is a tool condition, right? This tool condition will go and see what are the tools available in my entire graph. So the tools available here is the tool node. Okay, this tool node will be attached to this tool condition. Okay, and now my conditional edge is now ready. So my conditional edge is between assistant and tool condition. Okay, and now I'm adding one more edges from tools to assistants. Okay, now if you see this, my assistant is connected to tools. Okay, my assistant here is connected to tools, and also after tools is generating some response, it is again connecting back to assistant. Okay, after tools generating some response, it is going back to the assistant once again. Okay, by this edge. Okay, now after defining our tools and after defining our nodes and edges, so there is one more additional thing, memory saver here. Okay, this memory saver, this is actually a check pointer. Okay, this saves the state at every step. Okay, so there are multiple nodes, right? So this checkpoint, this memory saver, it saves the output of that state at that particular step. Okay, it is very critical for human in the loop, because uh, by this memory saver, we will pause, we will inspect, and we will resume our execution in between. Okay, so that's why we need this memory saver to save the state variable, to save the state at each and every particular step. Okay, and now after memory saver, we are compiling the graph. So now we build the entire graph with these nodes and edges, right? We integrated tools, everything. We added conditional edge, everything. And now we need to compile it. So in order to compile it, you need to use something called as dot compile. So now this is your builder. You need to use builder dot compile of this thing. Okay. If you see this, inside this, there are two parameters: interrupt before and check pointer equals to memory. Okay. So this line is what it makes the human in the loop. Interrupt before equals to assistant. Okay, let me explain you this one more clearly. So this builder.compile, it will take our graph definition and it will create an executable graph. Okay, this compile, it will take all of this graph definition and it will create an executable graph. And now this interrupt before equal to assistant. So here where the entire magic is happening with this with just this single line, with just single parameter, interrupt before equal to assistant. So here what it does is before executing. So if you see this interrupt before, I am passing assistant. That means before executing the assistant node, it will pause. Okay, interrupt. It will interrupt before executing this assistant. Okay, and after interrupting it will wait for human approval, okay, or else it will wait for human input. It will don't proceed until explicitly human told to do. Okay, here it will stop execution before this assistant. Okay, it won't proceed. Then we have something called as check pointer equals to memory. So we already, our memory saver, it is saved inside this memory, right? So we are passing this memory to this check pointer. Okay, it save state at each and every step using our memory saver. Okay, we initialized this memory saver, and then we included that memory saver to this graph. Okay, to this graph, right? Now this memory saver, this will allow us to inspect state at each and every level. Okay, if you want to modify state, we can do that, because we can able to inspect state at every point, right? At that particular point we can modify that state variables also. What does the state contains? It contains the flow of messages, AI message, human message, everything. Okay, and then after this, after modification, it will resume from where it stopped. Okay, and then so here if you see this, in order to, now we built our entire graph, right? So we built the graph with node, edges, condition edges, we integrated tools, everything. And also we integrated human in the loop, we integrated memory saver, everything. So now our graph is ready. Now we need to see that graph, right? In order to see that graph, we need to use this display image, okay, which we imported before here, image display from ipython.display. It will display our graph, okay? So there is something inside image, we need to pass our entire graph, where our entire graph is stored inside this graph variable. Okay, if you think is builder.compare, so it contains entire graph structure which is stored inside this graph. So I'm passing that graph, and inside graph, so there is some function called get graph draw animate png. It will display our graph. Okay, this function. So now if you see this graph, it is a visual diagram. Okay, if you see this, there is an interrupt equals to before at assistant. Okay, see this label interrupt equals to before on the assistant node. Okay, so this is what our human in the loop. So this shows the interrupt point visually here. Okay, whenever this assistant node is executing, it will interrupt before this execution. Okay, there are also some more things. So you no need to use this interrupt before. There is also called as interrupt after. If you want to interrupt after this assistant node execution, then you can use this interrupt after instead of interrupt before. You can use interrupt after. See, this interrupt after is coming. Okay, so but now I'm using interrupt before. Okay, interrupt before and interrupt after. So this is your graph, right? Now, so now you build your graph. If you see this, this is your start node, this is your end node, this is your first node, assistant node, and this is your tools node. Okay. And now your start is connected to your assistant is connected to tools, and again your tools is connected back to your assistant. Okay. Based upon the condition, if it needs to call, it will call this tool nodes. If not, it may directly go to the end stage. Okay. This is your graph. Now, so now if you see this, I'm initializing some thread value. Okay. So thread configurable thread ID, whether what is this is. So this is like this thread is nothing but a conversation ID. Okay. Here here the thread ID I am passing here is whether 123. Okay, this is a unique thread ID. Okay, each unique thread ID, it maintains its own separate state or own separate memory. Okay, just think like this thread is nothing but session ID. Okay, your session stores some particular information, and if you start the new session, that information will be lost and again new session will be started, right? So this thread actually it holds the state or memory, okay, of that particular conversation. Okay, So we need this thread, okay, to store the separate conversation. Okay, so this is like session ID. Okay, next next thing is initial input. So this is the input. Now our graph is ready, right? What the thing here missing is the human query. Okay, now how I need to pass the query here. Okay, let's say where I need to pass the human query inside the state messages. Okay, I already told you. So there is a message state. Inside message state, there is a predefined messages variable available in your message state. Okay, so we need to pass the input in this form. So you need to pass in this way, in this dictionary way, in the form of dictionary, where the key here is messages. Why? Because the messages here, because your state already contains the messages variable, so you need to initialize messages here, and inside messages you need to tell your LLM. So this, as this is a human message, so already you imported this human message. So inside human message, you need to pass the query in this way: human message of content equals to and your query. Okay, you need to pass your query in this way. Okay, so inside human messages content, so here you will write your query. So my query here is, what's the temperature in London? Okay, what's the temperature in London? This is the human query. Now I'm executing this. My input is ready. Now I need to pass my input to my graph, right? So now if you see this line for event in graph.stream, see this. Now this graph.stream, it will start executing the graph. Okay, if you see this, the entire graph is stored inside this graph variable, right? That's why I'm using this graph, and inside graph there is some function called string. Okay, so graph.string, and inside this I'm passing these parameters, my initial input. So I'm passing my input, and also I'm passing my thread, my session ID, and also there is one more parameter called stream mode equals to values. Okay, the stream mode equals to values means it will string the entire state value at each step. Okay, what it will do means uh, it is, I mean, like it will go at each stage execution, it will stream the entire output. Okay, whatever the metadata it is having, the backend information, the AI messages, the system messages, the thinking it is doing, it will print everything. Stream mode equals to values. Okay, so now inside this graph.stream I'm passing my input rate and stream mode equals to value. So this is an option. If you don't want, you can delete this one, so you will get the normal output. Okay, and now I'm also, so if you see this for event in graph.stream, okay. So inside graph.stream, there may be multiple events. That means, so human may pass multiple inputs, right? So that's why for each event, for each input, so for each event in the stream, I'm taking the messages from the state and -1. So messages of -1. That means messages of -1 means inside my messages. So your messages are in the form of string. Sorry, your messages in the form of list. I'm taking the last messages. Your -1 indicates I'm taking the, I mean, it's the reverse indexing. Okay. Inside messages, it will go through the list of messages and it will take the last message and dot petty print. Okay, this petty print, it will displays the content nicely. Okay, in a neat formatable. Instead of simple print, I'm using petty print. Now if you see this, I passed my initial input, right? Human message. See this human message. What's the human message? What's the temperature in London? See this. Now if you see this, this is a human message, but the total execution of this graph is not completed. Why, we'll see. So now I'm just, what I'll do here is I'll get the current state of the thread. So every session is maintained in the form of thread, right? If you see this inside graph, there is a get state function. Okay, if I pass my thread, if you see this one state dot next. So inside state, if I use next, it will get what the next node it needs to be executed. If you see this message, so this graph is not executed completely. It stopped somewhere. Why, we need to understand, right? So first I'm checking the state. So inside the state, there is a get state. First, I need to get the state, and then I'm printing what's the next state. Next thing, next node it needs to execute. If you see this, the output here is assistant. That means this is this confirms our execution is passed here. Okay. If you see this, it is telling the next node it needs to be executed is assistant. But here it not executed, it stopped, it passed. Why? Because there is a checkpoint over here, interrupt equals to before. Okay, there is a checkpoint over here, that's why it stopped execution after this human message. There is no AI message here. Okay, we are passing the temperature, we are asking temperature, but there is no AI response here. Why? It is stopped its execution. Why? Because we used this interrupt equals to before, right? So if we want to get the state history, we can use this function get state history. Okay, so this is my enter state value, so messages. So this is my state variable now, what it contains. So inside my state snapshot, there is a messages. So inside messages, there is human message. So now the human message is stored inside our state. What's the temperature in London? And there, these are some additional metadata parameters. Okay. And now it is also storing this information next equal to assistant. Okay. So it needs to execute the assistant node at next. And these are some additional parameters. So thread ID is feather 123, and also there is a checkpoint here. Okay. Checkpoint ID. Okay. So we initialized a memory saver, right? So these are some metadata of our state. Okay. And next, so our process is stopped here, right? So our execution stopped there. Now we need to continue execution. Why the execution is stopped? It is stopped for some human intervention, some human input or some human feedback, whatever. Okay. Now, now the control, now the ball is in our code. So we have the control now. Okay. So the execution is stopped. So let's say now I need to, let's say, I don't want to make any changes now. Okay, I just want to process the information, process the execution. Okay, I need to continue the execution to this assistant. So in that case, again, I'm again using the same line of code for event in graph.string, but this time previously I passed this initial input, but now instead of initial input I'm passing none here. Okay. This means this argument means I don't want to add new input. Okay. Just continue from where you left off. Okay. I just don't want to add some additional information. That's why I'm just passing none here. Okay. Just continue from where you left off. And again, I'm passing stream mode equal to values. Okay. And I'm passing the same thread value. Okay. Because it contains the, it is a session ID, right? So it will be executed in a single session, same session ID. Okay. And again, I'm printing my messages. Okay. Now, if you see this, I resume my execution. Now, if you see this AI message, inside the AI message, so it is making some tool call. So inside tool call, it is calling this get temperature. As I asked about temperature, so it called this get temperature and some call ID. And if you see this argument, city London. So I asked about temperature in London. So city London, and unit by default it took Celsius. And now this is the tool message. So it executed this get temperature function, and now the temperature in London is 15 degrees. So it returned the output in the formatted string. Okay, the temperature for London is 15 degrees. If you see this, if you see this function London, if you see the value of London, it is 15 degrees. And the return statement is the temperature in city is temperature. Okay. So this is my tool message now. Okay. This is my tool message. Okay, now if I check my graph state, again it went back to assistant. Okay, state dot next. What is the next node to be executed? Assistant. Why again it went back to assistant? Why? Because if you see this graph, after tool execution, my control again going back to this assistant. Okay, that's why it is showing the next state as assistant once again. Okay, now again. So now again, I'm continuing the execution of assistant. So I don't want to again the control goes back to this assistant. So now I don't want to modify anything. I again passing none. Thread is again the same thread value, and stream mode again I'm printing my message. Now if you see this tool message, AI message. If you see this now The AM finally given the response. The current temperature in London is 15 degrees. Would you like to check the humidity level or weather forecast for London as well? Okay, it is asking this question also. If we want, we can again execute this function and pass the user input once again. If not, we can leave this as it is. Okay, and now, so this is the case where we don't want to pass some additional information. Now let's go and see this one. Okay, here again I'm taking this initial input. So inside initial input, so inside my messages variable, now my message here is what's the temperature in Paris. Okay, and again this time I am passing new trade value. Okay, before it is weather 123, now it is weather 456. So I'm starting the new session ID. Okay, again, so graph.stream, I'm passing the initial input, I'm passing my trade value, the new trade value, and stream mode equal to values, and I'm printing these messages. Okay, so see this human message, what's the temperature in Paris, and stop the execution. And if I see my next state, it needs to execute this assistant node. Okay, and again, now this time I want to update the human message. Okay. Initially, I asked for the temperature of Paris. So now we interrupted, right? So now I want to update the state variable. Okay. Let's say this is your graph, right? Inside your graph, there is something called as update state. Inside this update state, first you need to pass your trade. Your trade is nothing but trade weather 456, your trade value. And I need to update the message this time. Okay. Inside messages, human messages, content. See this. Now the message here is before I asked what's the temperature in Paris. Now the content human message is no. I want the weather forecast for Tokyo for 5 days. Now I modified the human message before this execution, before this assistant node execution. Okay, I modified this value. Now if you see this, now if you see the state messages, first the human message is what's the temperature in Paris. Now the human message is updated. See this from graph get state. I got my state value by passing this state, and now I'm checking list of messages. I'm checking what's the recent messages, recent updates made in my state. Okay. So if you see the state messages, first it has the human message, and now the human message is updated to this one. Before it is Paris, now it is Tokyo. Okay. And now I modified my graph state, right? Now I just want to continue with the modified request. Okay. And now I modified this state. And now again, I don't want to further modify this. So I'm passing none red stream mode. If you see this human message, now human message is updated with this one. Now I want the weather forecast for Tokyo for 5 days. Okay. So AI message. So now if you see this tool calls, it called the get forecast. Okay, this function. Okay, now the arguments here is it took the city as Tokyo and the days are 5 days. Okay, and it executed the get forecast, and the tool message is 5 day forecast for Tokyo is sunny, partly cloudy, rainy, cloudy, and windy. Okay, now still the execution is not completed. Now the control again goes back to the assistant node. Okay, now again I'm continuing my assistant. Okay, none by passing none thread. Okay, now if you see this tool call AI message. This is the final AI message. Here's the 5 day weather forecast for Tokyo. Day one sunny, day two cloudy, rainy, day three, day four cloudy, windy. So you might want to carry an umbrella. So it is also suggesting this message. You might want to carry an umbrella on day three. Let me know if you would like more details about it. See this is the AI message. Okay. So this is how this human in the loop actually works. So you interrupted before the assistant node, and then you continue the process, okay, by passing updated state, or if you don't want to change your message, you can directly pass it as none. Okay, so this is how you can integrate human in the loop in your graph. Okay, so this is just a simple demonstration. So let me quickly summarize what we seen just now. So this is an interrupt before execution. So we set some breakpoints with interrupt before, and the workflow passes before executing that node, right? Before executing that assistant node. Okay. So now human can review and they can tell what's about to happen. They can know what about to happen. And we inspected some states, our state messages using get state and dot next get state history. So we can inspect our state using these functions. Okay. And we also modified state by using update state. Okay. Graph dot update state. Okay. And also we called graph.string and we passed input, thread, and stream mode, everything to it, right? And also there is a memory saver where state, I mean, we can able to go and see this, go and fetch the state, right, using this memory saver. So, so this is, so like I can say, we covered a lot of theoretical and some practical stuff today. So let me quickly wrap up this and tie everything together for you. So today we started with the Langgraph basic knowledge, and then we went to some advanced topics like workflow integrations, workflow patterns, and different track patterns. Right? We started with understanding why Langgraph matters, why simple chains are great for straightforward tasks, but not for real-world AI applications, and then we explored about prompt chaining, parallelization, routing, orchestrated workflow, evaluator optimizer. These are five essential workflow patterns we have. And then we dive deep into human in the loop, why it is crucial, why AI is powerful with this future, why Langgraph is powerful with this future, right? So, and also we explore different advanced RAG patterns, agentic RAG, corrective RAG, and adaptive RAG, right? So, So, so imagine, so this LangGraph is not just simple framework, it's a big thing, okay? So it is shifting how our AI application should be. So it is moving us from AI does everything to AI and human collaboration intelligently, okay? This is making our systems much more intelligent and much more accurate and reliable, okay? So this is what for today. So thank you so much. So I think we covered a lot in these 2 hours. So now it's time for question and answers. So I'll go and see the chat section and see if you have any questions.
Yeah, I think feel free to raise your hand. Will allow to talk. Everyone, please. I know it's a little long session, but we want to give opportunity to everyone. Yeah, Patnak, please. You can unmute yourself.
Can you
Yeah,
hear me?
yeah, we can hear you. Yeah.
All right. Thank you so much for walking this through, right? Like you said, it's not easy, but I'm just trying to understand, right? Like in the current projects, right? So, in case if we have to implement any of these, just think from a financial industry standpoint. Do you think of any particular use case that you think, we can think through for all that implementation that you have explained today?
Yeah, partner. So there are n number of use cases. Let's say, so you have a financial organization, you are working on some financial stuff. So let's say you have a company and there is some customer care. Okay. So what the customer care will do, so they'll serve some customers, right? So customers can call your company and they may have n number of questions. Let's say, see, I have these issues. So I took your service, so but that service is not working fine. Let's say your service actually cost $50, but $100 is deducted from my account. So there are some n number of user queries, right? So now what is happening here? So that customer care, they're getting user query, and then manually back end these humans, some other backend team, they'll go and they'll analyze the user query, and let's say if the human is asking $50 credit to their account, and now human will go and query the databases. Okay, why the user is asking $50. So is this necessary for us to give $50, or is it $20 or $30? They query the databases, they fetch the information, they'll get some services. Okay, they'll query everything, and then if that if they want to give $50 back, and the user again once again they'll go and credit back the $50 to the user. Okay, so in this use case, manually human is doing everything, right? So instead of human, you can keep AI agents over here. So instead of humans, AI agents go and retrieve relevant information from the databases. Let's say it will go to databases and it will query for the user information. Let's say the user ID is this one, and the user location is this one, and the user query is this one. And based upon that retrieved context, it will decide, it will make internally all the calculations. Okay, last month this user paid $100, but actually they need to pay $150. I mean, actually, he paid $100, but actually, $50 need to be deducted. Some $50 extra is deducted from his account. And AI agent, it will make all of that analysis, and it will give back the response to the human once again. So if you keep the interruption in your workflow execution, and it will come up with all of the analysis. Okay. And finally, as a human, you will go and check. Okay. So this is the AI analysis. If that AI analysis makes sense, you will approve it. And again, the same AI agent, it will go and credit the whatever amount may be to the user account. So in this way, you can reduce the manual effort. So instead of human going and retrieve the information and making all the calculation, your AI agent is actually retrieving the documents and making calculations. So
Right.
this is one of the use case I can tell you.
So I think very good use case you told, right? I think interest of time, I don't think we might be able to go to next level. Is there a possibility for you to at least, send or cover us in the next class, right? The next level, right? So what you told is the requirement, right? Now what I want to know, or some others might want to know, is technically how this can be achievable with the agentic AI, right? Do we have to do the coding to put everything in Python, right? What technologies we have to use, right? If you could cover in the next class, or like if you can create a document share, I would appreciate that.
Yeah, exactly. So most of the people might interested in this. So till here, I covered most of the theoretical part, right? But this is not just a small thing. So you want to understand about different workflow patterns, different RAG-based approaches. So this can't be, I mean, you can't able to grab each and every information, each and every workflow in a single or multiple classes. That's why, so in our live classes, which we are going to start from November, we are going to take each and every topic, and we're going to explain each and every topic in detail and with some practical examples. Like as you see before, we talked about different workflow patterns and different RAG based structures, right? But here in this limited bootcamp time, I can't go and explain use case for that. I mean, the practical implementation for each and every workflow, as there are 5 workflows. If I want to explain use case for each and every workflow, if I take even a simple example, it takes me 2 hours to cover the practical example. So that's why the live classes, it will actually helps to, I mean, in the live classes I can able to, so me and along with other mentors, we can try to explain you in detail what are, we'll take some use cases and we'll explain in detail in those live classes. But here, as we have limited time, we can't able to cover all of these things in detail.
Got it. Thank you. Thanks, Ganesh. And if you could have some materials, you can pass some URLs
Yes,
or
yes, I'll
link.
definitely. So,
That will be great.
so
Thank you.
our team will send you that information and documents.
Thank you.
Thank you, Badnan. Ravi, please proceed.
Okay, yeah, thank you so much. I really appreciate the session you have took over from starting. It was like from the first 10 minutes itself, I felt it was very interesting for me. So even I partially attended the previous sessions, but I didn't know, but it was this much interested. But I really loved it the way you delivered the content and the explanation that you have given, and I would like to appreciate first. And coming to my
Thanks,
question.
Ravi.
Yes, and coming to my question, so currently, as you mentioned for one of the example, I could see like when you are implementing this it's agentic RAG, right? So there is scenario like in one of my within the organization, so we would like to get the some uh, what are the revenues and profits and also exact internal details. Just assume that there's a few or it includes the confidential details. So so how we are going to manage that security? Like so because we are using the agentic RAG, right? So in between we can pass the knowledge source as our internal documents or some required URLs. So it will go and fetch that required information for within the organization, and you are taking it and giving it to the AI LLM. So it is going to process to the user based on the question he asked. Okay. So in this process, I do not want like this entire like, confidential information to be given or exposed to the external LLMs or public sources. So how the security is or like this sensitive information is going to like do, I do not want to expose it. So how can we achieve it in any one small example? Like so, how can we do this? Is there any process
Yeah.
or is there any method? Yeah, is there any scenario that exists? Yeah, that's it.
Yes. So this is a great question, I can say. So you want your documents need to be private, right, and not to be exposed them to the some outside LLM sources, right? So in that case, for example, if you are implementing a simple project, simple use case, you can always run your AI models locally. You can run your models on your own personal servers. Okay. So if your company is capable of providing the own particular servers, you can use them. Okay, not the cloud servers. Okay, so it's just like instead of using API calls and calling the LLM from the chat block or OpenAI, you can directly download the ChatGPT model or whatever the model may be into your local system. That's the way you can prevent your documents going to the public. There's one of the way, but also if you're working for some enterprise applications or something like that, you can't do in that way. So you need to so that company actually, so we are not capable of doing that enough. So your company, they need to deploy the LLM, whatever the LLM they're taking, let's say it's OpenAI or ChatGPT LLM or Anthropic Cloud, anything. They need to deploy their own LLM to their private networks, to the private servers. So they need to, there will be some, I would say like policies between cloud services and our organizations. So that policy needs to be established, and we need to, that company needs to deploy own LLM to the cloud services by that some policy. So that policy means like that particular cloud company, whatever the OpenAI or whatever cloud Anthropic may be. So there might be a policy between your company and the cloud services. That information not, I mean that's like an additional security layer. So there is a policy between these two organizations that information need to be secured, and some additional, they'll add some additional network or security layers on top of it. Okay, that's one of the way you can secure your documents. And another thing is you can create your own vector databases. So you can create your local vector databases and store that information inside that vector databases. Okay, so that is one more way. And also, so these are some popular ways. Generally, organizations, they will deploy LLM models into their own cloud platforms. So that's how nowadays every company is doing, and there is some policy or some understanding between the cloud company and organization to not to, leak that information. They're adding some additional security features like OAuth or something like that. So there is some policy between them.
Okay. Thank you, Ganesh. I understood. Like, so instead of in a nutshell, like we should go for internal organization level LLMs and also
Yeah.
internal servers rather than exposing this information to the public or APIs, open APIs. Okay, got it.
Yes, yes. So nowadays, all the companies, so most of the companies, they're having their own private deployed LLM in their organizations, right? So that's how they're doing. So they're having some connection between. them and some there is a policy between networks, I mean network providers, solution providers.
Got it. So how simple is it creating the vector databases? Is it as simple as it, or it requires additional effort for the developer or organization to m- maintain the vector?
Creating vector database is just simple. So there are like currently there are like vector databases like Pinecone, ChromaDB, PostgreSQL, so which is integrated with PZ vector. So these are currently most widely used vector databases. I mean, if you go in deep to this LangChain and all, you can able to create vector databases. So it's just a developer task.
Okay, got it. Yeah, thank you so much. Yeah, that will be helpful for me. I'll take it forward from here, and I'll definitely dig into that. Thank you so much.
Yeah,
Thank you.
thank you, Ravi. Please try to enroll if you are really interested. We want to see you in the next batch. Okay. Ashok Kumar, please unmute yourself.
I and these classes will be weekend classes or it should be working day classes?
It will be weekdays and weekends also. Thursday, Friday, it will be night time, EST. 1 hour each day. Saturday, Sunday, it will be morning. For India, it will be 8 p.m. IST. For USA, it's 10:30 p.m. 10:30 a.m. EST to 12 p.m. 1.5 hour. Saturday 1.5 hour, Sunday 1.5 hour, Friday 1 hour, Thursday 1 hour. So 5 hours in a week.
Okay, what time? What time on Friday and Thursday?
9:30 p.m.
Indian
EST
time.
to 10:30. In India, it's 7 a.m. EST. Sorry, 7 a.m. IST.
7 to 8.
78, correct. Yeah, yeah,
Okay, okay.
yeah. I know it's little difficult for India, but that is how it
And
works. But
what is the syllabus for the regular classes, live classes?
yeah, syllabus we have A for coders and A for non-coders. So in A for coders, all coding concept, co-pilots, data science, A agents, agentic framework, all these like RAG, agent to agent. There are so many concepts, like 90 plus hours we teach for AI coders. So in that we will also teach prompt engineering, and we will also teach AI for cloud platforms as well. Azure, OpenAI, Amazon, Bedrock, Google Vertex AI, all these cloud platforms will be covered as part of course plan.
How long will be these classes?
It will take you almost 90 to 100 days. Even hours also, it will take 90 hours to 100 hours.
Okay, so it's 3 months. No,
Yeah, it's a
not
three
three,
months
more than
course. Yeah, 3 months course plan. When you enroll, we will give you in
no
advance.
90 days. You are saying all together 90 days, or the real classes on 90 days. If it
No,
is
all together 90 days. Okay, but yeah, +5 minus it will be there because we cannot give the accurate hours or when I look at last batch, it went to up to 100 hours. Okay, so if you enroll in advance, we will give you previous batch recordings access. We will also give you a couple of project access. You can explore and join for live classes for experience. And during the classes, we teach both projects and use cases execution and theoretical also. In GitHub, we will give access, right? So you can take clone the code and for each and every use case, and you can practice. So we will conduct query session as well. It's not like we complete everything in one batch, and if something projects are pending for practice and all, you can continue, and you can rejoin in next batch. You can we have product development as well, and if somebody interested in development, they can join in our other discussions as well. So there are many things going on.
so. What do you mean by the production? If somebody want to do an individual project, you will be supporting.
Yes, we'll support. Yeah.
What is your product development? If somebody want to do, I am not getting that point.
There are like we get AI related product development like chatbots development, computer vision projects, data science algorithms automation. AI for business we get like store automation, voice automation, restaurant automation. So everywhere like agentic implementation. So all these we are getting small business areas, so where you can involve in discussions.
This will cover the basic of LLMs like transformers, all that attention
Yeah,
mechanism.
in regular batch, we will be teaching like Python and LLMs, Copilots, cloud AI platforms, AI agents, data science algorithms. You will cover be NLP, natural language processing algorithms, deep learning. In data science, we also teach like supervised and unsupervised machine learning algorithms. Prompt engineering, we teach 10 hours, and we also teach two projects using prompt engineering. So multiple things like we also cover building a model and deploying in Amazon Bedrock and Azure OpenAI. So from no code side, we teach a lot of testing tools, project management tools. So we also teach like creating a bot using Google Vertex AI end to end. So all these are like various concept in our course plan. I will be sending if you are interested.
Okay.
Yeah. So try to enroll. There is a enroll form. Normally, if there are 5 people are interested, normally I conduct a Zoom session. I will go over all the stuff like what we teach, and we have recorded session also. What we teach as part of the 90 hours course, and what we teach. We have another recorded session. What we teach as part of projects also. So everything we have recorded sessions. We will send you that for quick reference. Okay. Yeah, but for now, if you want to upgrade to AA, in the chart we have an inquiry form. Fill that where our team chart individual one to one, and you can join one to one Zoom calls and get all the information. So I
Okay,
recommend
who
everyone to
the
join that.
instructor will be different instructors, with the same instructor will
There
be
are
continuing, right?
10 instructors. Like there are 10 people who come and teach different areas.
Okay.
Not one teacher. Prompt engineering teach by one, Python will teach one, agentic will teach by one, RAG will teach by one, data science algorithm will be two mentors, no code platforms will teach by 3 people. So like that, everybody having different expertise in different areas. We are kind of 8 to 10 people who come and based on the course plan execution, they will come and teach.
And how about the pricing for this? Did you post the pricing?
Yeah, pricing will be there. We already put the enrollment form, and if you once enroll, right? So pricing will be in US, it's $500.
Okay.
In India, it will be separate pricing. So if you guys reach me offline, I can help you.
And in these classes, right?
Mhm.
If any questions and all, will those be
Yeah, every like we conducted today, right? Every class
okay?
we give like 15 minutes query session, and every month we conduct additional query session, like 3 to 4 query session.
Got it. And how many folks will be there in each class? Like 10, or do you have any limit?
Minimum for 30 to 50, sometimes 50 above also. It's not more than 50 or 60. Last batch, I see like 60 people, but this batch maybe go beyond or maybe similar number.
Got it. You don't have a
Yeah.
smaller group classes, is it?
No, not small. Minimum 50 people will join.
Oh, thank you.
Yeah, yeah. I see there are 2 more people allowed to talk. I'm okay to answer related to course also. That is very important for everyone. Kishore, please proceed.
So, hi. So you said like there is a separate non-coder and coder, right?
Mhm.
All this Langgraph, Langchain, and agentic racks, all these concepts are coming under the coder or non-coder
Coders only, coders.
coders only.
See, but non-coders, it is really mandatory to understand coding concepts as well. But for coders, non-coders concepts not mandatory, but always better to learn.
Got it.
Yeah. So now for non-coders, you will be learning all LLMs like ChatGPT, Gemini, prompt engineering. Using prompt engineering, we teach like 2, 3 projects using Streamlit and ChangeLit, and we also teach AI agent, agentic frameworks. As part of no code platform, we also teach ClickUp AI, Notion AI, N8N, and there is a test management tool from there is a famous company Tricentris, so we teach that as well. We teach voice automation, non-voice automation. We teach how to effectively write the prompts to build websites, to build blogs. So all these will come under non-coders. So it gives you a very big knowledge.
Got it.
Yeah. So
To
people
be
thinks
able
like
to
prompting is like a charting. That's not the way it works.
the,
We give like prompt one pager prompts where you put it in different specific tools. You will get your blog, front end, back end, and even DB schemas also. We can build the code within 1 2 minutes. So those techniques we will try to teach everyone.
do the course will cover building the website using AI?
Yes, yes, yes. We have 5 hours
So in
5 hours course on
in which framework you are doing that? Which framework you will be
yeah, we
using for
use we use bold.new, we use base 44, we use Lovable. There are 3 tools we use for
no, that
building.
platform I am asking in terms of software framework like Django or something like that. Now that will be using that framework, or you will be
No, it's a AI-based applications which will be
Yeah,
used for
yeah.
the web development, not for the
Mhm.
Django. The Django comes under behind the scene of that. AI tools will use, not direct AI platforms.
Correct.
no, no. I am asking where you deploy. When you deploy, there will be certain framework to connect between backend and front end. All these things are there, right? So there will be even though code will be generated by AI, but there will be some framework
Yeah,
we will
I mean
be.
you can use like any integrated development like VS Code or GitHub Copilot. You can use any development platform.
So those platforms are just like your ChatGPT, but these platforms they are specializing in generating full stack applications. So just like your ChatGPT, these applications.
Yeah, that's why I'm asking with the full stack. Are we going with a full stack application development or just how to demonstrate how to generate a
Yeah,
code for some
exactly.
front end, back end, that kind of thing only will be happening? Or there will be a
Yes,
full
yes.
stack application will be developed. That full stack application have different frameworks. That's why I'm asking the Marine or something. There are so many frameworks are there, right?
Yes. Yeah, I understand your question, but we are not going to work on building full stack applications. We are just going to see how that platform helps us, how that AI platform helps us to generate code for front end and back end, and if we have any errors in between, how to rectify that errors. So these platforms, these are specializing in developing full stack applications. So we'll see how these applications helps us to create code in a very fast and easier manner. So it's just like in
Yeah.
between. So you'll just see this AI applications, no code tools, how to use this no code tools for making our work very easier.
Yeah, in our use cases, we will teach Microsoft Copilot Studio and we also teach Codex. We also teach GitHub Copilot. So that's where our developers come and teach like how to work with those tools and what things to be installed. So those will be covered for learning purpose. Yes,
Okay.
we can. I think we can proceed.
Yeah, just was wondering if you had like a 1 month course. Is it like because 3 months? I don't know how the scenario might change. That's what I'm thinking.
Yeah, but 1 month we cannot cover the I mean it's difficult to cover in 1 month because this is like well designed from our mentors. To understand Gen AI, you need to understand basics of Python, machine learning, and data science algorithms. That itself took 30 days. And then we teach no-code tools, we teach LLMs, we teach copilots, we teach fundamentals of LLMs, we teach effective writing of prompt engineering, building projects using prompt engineering, and then we'll go advanced AI agents, agentic framework, RAG, and building. There are hundreds of concepts like vector
Mhm.
DBs, embeddings, Hugging Face. All these like they will teach as part of model training, model building. Even also they teach deploying these model into Azure, OpenAI, Amazon Bedrock, and they will show you how it runs, CI/CD pipeline, and they will also show you 2 3 models building with efficiency. They will teach you how to labeling, how to where to deploy the models, where to host the models with efficiency, and they will also ensure that how evolution performs. So all these like as part of in a sequential manner. Let me show you my course plan, because there are people are like very interestingly asking. Uh, so I'm not sharing this to everyone, but so this is how we execute, like all like chart GPTs, Python fundamentals, and then we teach all the data science algorithm, project management tools. Like 20 to 30 hours we teach on basics of machine learning, NLP, data science, and then we teach on no code tools, prompt engineering, and we also teach like how these chart GPT behind the architecture transformers itself we teach like 3 to 4 hours, and then we teach like some no code tools, and we start teaching on the cloud AI components. Google Vertex AI will be cover like 10 hours from basic to advanced topics from end to end. And then we teach like fundamentals of GenA, vector DBs, embeddings. So all these like you in a sequentially you will cover. So whatever I am showcasing all these concepts like with the last concepts are very very advanced concept. We teach 10 hours of theoretical and practical also along with projects. All these are like very
Okay.
high level. And along with that, for non-coders, we teach like some of the project man tools where AI tools can be leveraged, end-to-end flow and also these classes are like 20 plus hours. So when no coders are concentrating both for coders and no coders, they can easily, clear the interviews, kind of prompt engineering, data analytics with AI, data analysis with AI, and they can also go like a support engineers. They can also go a ethical engineer. They can go as a project managers, a technology managers. Once they learn all these 100 plus hours, right? So you will see the path of how to explore and where to explore, where to go. So you will get like a very high level foundation knowledge, foundation intermediate level.
Mm-hmm.
So, and we will upload all these projects in GitHub. There are 30, I spend like almost 6 months to design projects, 30 plus projects we design for every use case. So everything will be in the GitHub, whoever enroll. So we will explain 5 to 6 projects during the classes. The remaining projects we will give access to practice. So in GitHub, if once you enroll, you will get access and you can practice more use cases.
Okay.
This
Yeah.
is lifetime access.
Uh, one second.
Yeah, we'll give lifetime access. Correct.
Yeah. One question is like, if you have any product or tool idea, will you be helping us? Like, maybe it will come in the last session to develop.
Yes, we can help you on that. We have demoed to some clients on the product development. I will if you can ping me offline, I will give you the recorded session. Okay, sure.
Okay. Okay.
Yeah,
All right. Thank you.
no problem. I
This
see
one
some.
fine tuning you will be doing for that LLM fine tuning.
Ganesh, maybe you can answer the question.
The fine tuning here mentioned is the LLM fine tuning, right?
Yeah, model
Exactly.
fine.
Yeah.
Yeah.
Fine-tuning LLM using LoRa techniques.
Okay. Okay. Also, is this cover any analytic part, analytic things, the other than the NLP? Any numerical analytic part also is covered? Any tool like for numerical data analytic?
Yeah, it will be covered as part of data science algorithms, where we explain each and every algorithms with data visualization and analytical side as well, but not a complete detailed course.
Okay. In
Yeah,
time series also is it covering time series related to anomaly detection?
it
Time
covers.
series.
It covers. Yeah, covers.
It covers Arima, Zarima, and all will be covered.
Mm, yeah, because
Yes,
I'm
yes, it
not.
will be covered. Yeah, that
Yeah.
time series part, those will be covered.
Okay.
Mm. Yeah, if you are really interested, try to enroll the course. Enrolling doesn't mean that you are fully enrolling, but for information purpose, you can enroll and you can clarify all queries offline. And then, if you're interested, you can pay and join for regular batch, which starts from November first week. Yeah, we successfully executed this plan in last 4 batches. Almost we spent boot camp projects, development activities, all discussions. We conducted almost 350 plus hours. So far we conducted 350 plus hours, which are recorded. We have everything in Zoom cloud. And once you enroll, we will give you a sequence of 100 plus hours of recorded sessions for as a prerequisite. You can listen in prayer and join live classes. I mean, if somebody is serious, we will give you, access in prayer as well. Yeah, you can just open the chat room. You have enrollment link sent by Indraja. Try to enroll it. So this is the link. I see it. Try to enroll it, this doc Google form, so that I mean, we can discuss offline, or you can reach out to my US WhatsApp number +14708616312. I'm happy to support offline as well. Yeah, so finally, just to before ending, we are not commercial. We are trying to help our students. So mine is like a startup. I started in India as well. So in India, I started like weorganize.ai, and here I started for training. I started KKR Chennai Innovations, but training and placement I started in India. Weorganize.ai. That's like pure product development company. But I promise everyone that you learn something from us. Okay.
The
If there are,
subscription and all you are giving, the student ID and all something is given because there are so many offers with the students IDs and all. So
we
that is
help
kind of
we
you
help
are
on that tools wise and learning LMS. Even if you are interested, I will give you some discount codes. That's the reason for asking the enrollment form offline. I will help many people. So if you are really interested, you can fill the inquiry form. You can ask me offline whatever the help you require, because in public forum I cannot promise because there is a unique process. But yeah, if you're a student or if you're really need some help in projects or placement, anything, I've been working on this exercise from last 3 years. I was into consulting from last 10 years in US. So definitely I will help whoever is needed. It's not only
okay.
training, we help on the placement and training also. We have separate 20 members team from India, who help in both marketing and helping you guys wherever is needed. Yeah, Ganesh, we can drop off. I know you spent a lot of time. I will be spending next 10-15 minutes. If there are any specific questions to course plan, but you can drop off, Ganesh. No issues.
Thank you so much.
Yeah,
Thank you, everyone.
thank you.
Thank you, Ganesh. Thank you.
So,
Yeah,
one question is we can connect with people who got placed and who are
yes,
already
yes.
working in AI
Correct. I
related
will
courses.
accommodate that stuff. Don't worry, Srikanth. I will accommodate. Because in my experience, I see like 14 people who got placed, STEM, OPT, H1B, and other green card experienced people, whoever came to my area in last 14 months. So they all like, yeah, I mean, I cannot tell, but some people got like per hour $100 also.
Mm-hmm.
Once we have one of my mentor also, Ganesh, I think he got recently in AT&T. It's a very good package. And there is another guy who teaches MCP. He got placed into LexisNexis with $95 per hour. Venkatesh sir, who is earning 60 lakhs per year, a architect, he is also traveling to USA. Yeah, there are good people like Shaker Master. He worked for MetLife and he joined like a 5+ years H1B experience in India and here, and he came here. He taught like almost 8 months, and 3 months before he got good job as a data science architect in MetLife. So and he has huge knowledge. There is no doubt about it. Yeah. So I have one lady who is working as a Google Vertex engineer in Wells Fargo. She will be teaching like 20 hours. And I have project manager and no code expert Aparoop, and he will teach 10 to 15 hours from no code tool side as well.
Okay.
Yeah. So overall, we have 8 developers, 1, 2 architects. They will come based on the requirement, and they will come and teach as per the assignment, and they go.
If you register for coders, you will be providing the this thing support this for no coders also, right?
Yes, sir. Yeah, no coders. It will be like 60+ hours. Coders, it will be 70+ hours. We will give one fee. We will give classes to both, so you can attend both classes.
No, I'm saying the recordings of no coders also will be shared, or
Yes, yes, yeah, yeah.
okay, because some part of that will be useful for coders also.
No, yeah, for now, no coders will give coders recording classes. For coders, will give no coders. So that will give you complete access. It's not like ending a course. It's like you can join as many as discussions. Once you enroll, you will have access to next 1 year if you want to learn full-fledgedly. So there is nothing like we complete in 90 hours and then you will be given you will be get notifications to join next classes also. You can join if you miss. If you feel live experience, you can join at any time, any batch. It's not like a training. There are multiple opportunities, and I will be launching AI for business in next year, April. You will be given free access if you enroll for coders and no coders. That course, Imagine, I'm charging like 1,000 to $1,500. Very huge plan I'm doing. That is for like entrepreneurs, business automations and all we are doing. There is a plan going on. So whoever my students in this year, they will be given access to next year also. And from USA, if somebody in Alpharetta, Atlanta, they can come to my office. It is 11535 Parkwoods Circle, Alpharetta. It's nearby Spices Hut. You can come and join in my office also. There are like 5, 6 people joins classes from my office also. If you are nearby, you can come and join in my office. I think some people raise the hand. Jagadish, right? Hey, hi Jagadish. Sorry, I didn't see your. You can unmute and talk, Jagadish.
Yeah, hi. Yeah, I have query like means how are the timings? Is it like on mornings or how many
Are you
hours
from
we will
India
be?
or USA?
I am from India.
Oh, yeah, for India, it will be Saturday, Sunday, 8 p.m. To 9:30 p.m. Night time. Both Saturday, Sundays, 1.5 hour, 1.5 hour. And for Thursday and Friday, it will be 7 a.m. to 8 a.m. 1 hour. 1 hour, 1 hour. 5 hours in a week.
Okay.
Yeah.
Understand. So like, don't we have like a daily sessions?
Not daily sessions, only Thursday, Friday, Saturday, Sunday, 4 days in a week.
Okay, the
Mm.
290 days, like a 3 months
Yeah.
session
There are
or a day.
sessions. There are sessions Monday to Wednesday also, but it's not a compulsory sessions. Like if I get some project or discussions, I will involve there also. If you want, you can join the project discussions, planning discussions. I get some business and I will involve everyone, whoever is really interested to contribute to our projects and all. So we can join there also. But those are not like mandatory or compulsory.
Okay. Like the course will start in November, right? So till
Yeah.
November till January it will continue, right? You're saying like
December, January, February mid or February end. It will go till February end.
oh,
Yeah.
okay. Okay. Yeah, I will. Yeah, means I
Yeah,
will
you
go
can.
through
You
the
guys can
course.
refer my YouTube also. There are like some sample sessions and everything uploaded. So you can just refer. There are like 900 people registered. You will see all the videos here. Some of the classes we uploaded here. So you can just see like how things, just to like there's some important sessions we uploaded. You can see in YouTube also.
KR Gen AI is transforming AI through innovative training.
Okay.
I missed last 2 days classes, so can I get recordings of those
Yes,
classes?
I will help you. Did you join the WhatsApp community?
WhatsApp. Yes, I joined WhatsApp
Okay,
community,
then I
right?
will post there. Okay, or you can also refer in my YouTube.
Okay. I see
Yeah.
in YouTube a lot of classes are there, so I don't know which one happened
No, you
day
can.
before
You will
yesterday.
see like very straight heading, like
Okay.
day 1, day 2, day 3, day 4, something like that. Okay.
Okay. Then
Yeah.
I'll reach out to there, and if you need any
Anyway,
help,
we'll
I'll.
communicate in the WhatsApp community group. That is the main forum we publish everywhere. So
Sure.
you can just like maybe by this Wednesday you will see all 4 recordings.
Okay, sure.
Yeah.
Thank you.
Yeah. Yeah, thank you all for today's session and joining. Make sure you all join next week also. Very, very interesting topics next week.
I have one last question.
Yeah, go ahead, Kishore. Yeah.
Yeah. Will you consider OPT students as
Yes. Yeah. I'll help OPT also.
well? Okay. Thank
Yeah.
you.
So next week we have different frameworks, NA10, and there is another tool also, Notion AI and Crew AI. Crew AI, it will come under AI agentic framework. So we have 4 hours of session. Please join. Okay. There are like 6 more hours, like we are not 6 more, almost 6 plus 10 more hours we have pending bootcamp classes next upcoming
Will
weeks.
you share the code also during this bootcamp or?
Code we yet to decide because there are people misusing, so that's what I'm not sharing the code. But 1, 2 projects, if you ping me offline, I will share. Okay.
Whatever you're covering in the bootcamp will be repeated in the main session, right? Your live
It
sessions.
will be repeated, but different projects.
Okay.
Yeah. But in classes, it's different. In classes, they will explain each and every package, how it works, like sequentially they teach.
Okay.
Yeah. I see everybody's we answered. I know it's late. If you have questions, you can stay back. If you don't have questions, I think, thank you, Ravi. Please feel free to exit and yeah, happy remaining weekend to everyone. Thank you all.
Thank you, Kulandra.
Yeah, no problem. Thank you. Yes.
Thank you.